I'm just going setting it up.
Okay,
Obuli is saying
we'll wait for another 3-4 minutes for others to join.
Obuli says he can't unmute himself.
Okay. Yeah, I just saw the message actually.
Okay, guys, so we are live on YouTube.
Fantastic.
Okay. So
yeah. Okay, we'll have to wait for Kirti to join anyway. Where is the YouTube link actually? I think I saw it somewhere here. Okay.
I've just
Naveenji, we also have to start the recording once we start.
It's already going live, so it should be on the video.
Oh, okay.
We are already live. People are already watching us.
Oh, 21 watching now. Okay, all right, yeah. Awesome. Okay, so we'll wait for Kirti to join.
I am at Gurgaon and it's quite clear over here. I can see the moon. It's the 4th day today, and I'm just waiting for Mars to appear just below 4 degrees below the moon. It's a conjunction today. I hope to show that live when my turn comes. I'm lucky to have clear skies. What about other places?
It's cloudy here in Coimbatore.
No, the Bangalore is, right now it is clearing up. Moon is amazingly visible.
Oh, very good.
Yeah, I think Mars also is actually visible. I can probably, I think Mars is also visible. Mars is also visible. So,
Okay, who's presenting it for Bangalore, from Bangalore?
Kirti will present it.
Sudhash, could you call him on the phone, Kirti? Let him join and start the proceedings.
Yeah, he's joining actually. He's already there almost.
Okay.
I think Sudhash, you can start with the introductions and can kick off the
Kirti is here.
session.
Kirti is here.
Hi, can you guys see me now? Can you guys hear me properly?
Yes.
Oh yeah, okay.
Okay.
Let's see you.
Yeah.
AKP, yeah.
So exciting that today the sky is also clearing up. So we should be able to see something.
Okay, nice.
Yeah, definitely, yeah.
Okay, so
Okay.
do we have enough number of participants to start, or what do we do?
We should
How
start.
many?
It's time.
YouTube, we have about 35 watching, and in Zoom
Okay.
we have, I think we have just crossed probably, how many? 60?
Okay.
Okay, I think we can actually start. Let me, am I the, okay, I am the co-host actually, so let me share the screens actually. Yeah. Okay, Naveenji, I need permission to share my screens.
You have the permission to share the screen.
Yeah, got it. Yeah. Okay, Naveenji, Okay, if all of you can actually see the presentation,
Yeah,
I have a
yes,
I have a problem in if I present it from this one, it goes off. Something happens. I'm not sure what. So I'll actually go through this PPT itself directly. Okay.
all right.
Okay, so welcome everybody to virtual star party by Bangalore Astronomical Society. Given the current situations, we were unable to host a proper star party anywhere else actually. So this is our initiative to engage all of you who can't come to a remote location, as well as engage the audience in some way that we can all share our common interest and discuss about things that we all love. Okay, so without much further ado, very warm welcome. So just an introduction caution that the cyclone which has been in the Arabian Sea has actually a devastating effect on astronomy. So our presenters are trying their best to show whatever they can. So the format of this virtual star party is something like this. So we have our presenters from Bangalore, Coimbatore, Kolhapur, as well as Gurgaon. Okay, so we will take turns to show pretty much whatever they intend to show. We would definitely like to see Moon Mars, which is a conjunction today, as Ajay just mentioned. We'll also see if the sky is actually becoming more and more clear. We should be able to show you probably some asterisms or some other deep sky objects like open clusters or some other clusters. Let us see actually how things go. So the format is that the first few minutes our long-standing member, Mr. Kirti Kiran, will present an introduction to night sky using Stellarium. We will actually stop the screen share, and he will do the screen sharing from his side and actually describe what is available in the night sky today. If you look up what you can actually see, then followed by that, he has set up his telescope so we can see Mars and Moon. It is clearly visible right now in the skies, except some clouds are there, but otherwise we should be able to actually see some clear Moon and Mars. Let us see, and then we'll move on to Obuli Chandran from Coimbatore. He will describe about what he has. Currently, the Coimbatore skies are actually pretty bad, so probably he'll actually show us his setup and what he has actually shot through that and explain about it. Then we will move to Mihir from Kolhapur and to see what he has in store for us. Then we'll move further north to Ajay from Gurgaon to see what he has in actually store for us. And then we will come back to south again with Ganesh Raja. So each of us will have about 15-20 minutes of sessions. They have set up their camera, etc., and then they show us the live views if it is actually if the skies are clear. Otherwise, they'll explain their setup and what they actually shot before using those. Of course, you can ask individual presenters question and answers. No issues at all. We'll take them up as soon as necessary if it is directed towards a particular presenter. Otherwise, we will probably take up a question answer session in the end. So this is the format of the presentation. Now, what you should do to set yourself up till the time you're actually if you have some time now, install one of these applications in your mobiles. These are available on both Android and iPhone platforms, iOS platforms. So you can actually either install Stellarium or Sky Safari or Sky Eye, and there are many others as well. So this has been used by our BAS group of members a lot of times actually. So we have a lot of experience in these softwares. Of course, there are many more which are there as well. So if all of you are listening, then install one of these applications on your mobile. Then whatever we try to explain, if you can actually point your mobile to that particular direction, you should be able to see some stars and identify those stars, constellations, or sky objects, whatever. Okay. So this is the basic introduction part. Of course, these are all Corona times, so prepare yourself for not venturing out too much, just in your terrace or balcony, whichever you can actually see the skies. Please do exercise caution and do the same. Okay, if Kirti, if you are ready, then you can take over.
Hi, can you hear me?
Yes, Kirti, we can hear you.
Yeah, just give me 2 minutes. I'm just setting up, or I can probably share my screen and try to do this live. So what I'm trying to do right now is I have my equipment, which is pointed at the moon, and I'm trying to show that. So before I do that, I can also probably try to show my equipment. Just a second. Yeah. So are you able to see my video? Yeah, I think maybe you should pin my screen so that everyone can see my video.
Kirti, just go ahead. I will help you out with that. So just go ahead.
Okay. Okay. All right. So I'll just try to show my equipment. So yeah. So here you can see my equipment. So this is this telescope. It's a 8-inch f4 telescope, which means if you see inside there is a mirror, and the diameter of the mirror is 8-inch or 200 mm, and the focal length of this telescope is 800 mm. And then you can see that I have connected my camera to it. And this is a DSLR camera. This is a Canon 60 DSLR camera, but any DSLR camera can be connected like this, and that can be used to capture the objects in the sky. So now currently I have pointed this to the moon, and so what I'll try to do is to show you the live view of the moon from my camera. Another thing is that this whole setup is on something called as an equatorial mount. So yeah, maybe you can see this now. So it's a stand on which the telescope is sitting, and this has motors inside it. So when so as the time progresses, because the Earth is rotating, the objects in the sky will move from east to west. So we need some kind of a tracking device, and this mount is the tracking device that tracks the telescope over time and makes sure that the object that we want to see is always in the field of view. And so this whole setup is on a tripod. So basically you can see that there is a tripod here, and then on top of the tripod you have the mount, and then on top of the mount you have the telescope, and the telescope is pointing towards the moon. So let's now try to connect the camera. So just give me a second. So my wife Kavya is helping me with all the lighting and all that. Thanks to her. So let me share my screen. Okay. Are you guys able to see my screen?
Yes.
Okay, that's great. So this software, it's called Eos Utility. So it comes with the camera, and here you can just go to live view, and we will be able to see the object in the sky. So now here you can see that see the moon. So basically it's a crescent moon, and I have pointed at that. So let me try to reduce the exposure a little bit. So here you can see the exposure, and as I decrease the exposure, okay, so this is the minimum that I can set. Okay, so maybe maybe I have to go to manual mode. Yeah, so here now I can set the time as well, and as I increase the time, we should start seeing the moon. Yeah, so now we are able to, we are starting to see the moon. I can probably increase the ISO a little bit. Yeah, maybe a little bit more. And then there are clouds. so yeah, so now we can see the crescent moon. I'll try to focus it a little bit better. So now it is defocused. So I'm coming back to focus. So this is pretty crisp. And now here you can see many craters on the moon, right? So this is at 5x zoom, so I can reduce the zoom, and now you can see the full view of the sensor. So if I zoom in, you can see a small part of the moon. So yeah, at this point of time, probably you can also go out and try to see the moon through naked eye, or if you have binoculars, you can try to see through binoculars. And there are all these very interesting craters on the moon. And what happens is, in different phases of the moon, you can see different craters. So there are clouds moving in and moving out, so it's a bit bumpy. So basically, you can see that here the light from the sun is coming from this direction, right? So that's why we are able to see this side of the moon. And also in the sky, if you go out and see, the moon is actually in the west direction, right? So the sun has set in the west direction, and the moon is also in the west direction. So the sun which has just set, its light is falling from this angle on the moon, and we are able to see the craters in this part of the moon. Another thing to notice is that if I just increase the let's say the exposure a little bit more, maybe.
Kirti,
Yeah.
if the exposure shutter speed is selected, you can use the left and right arrow to increase or decrease. If you press up, it will go to the maximum. If you press down, it will go to the minimum. Thanks.
Oh, okay, thank you. Yeah, so
here, what I wanted to show you is that there is, so we can see that, okay, a part of the moon is lit from the sunlight, but there is the other part which is also still somewhat visible. And this effect is better if you see the moon through a naked eye. Here I have clouds, so it's pretty bad, but I think you can still make out the shape of the moon here. So there is some light falling here. And can anyone guess what this is? Like why? So the sunlight is falling from here. So the sunlight is not falling on this side, but still we are able to see the moon on this side. So if anyone can guess, please type your answers on the chat window, maybe. Yeah, exactly. So I think many people are giving the right answer. It's called the earth shine. So which means the sunlight is actually falling on the earth, and then the earth, the light from the earth is falling on the moon, and then it is again getting reflected from the moon and coming back to earth. So that's called the earth shine. So right answer, guys. Nice work. So yeah, let me just try to decrease the exposure a little bit so that you can see the craters a little bit better. So now if you want to see which craters we are seeing and all that, we can go to Stellarium. So the Stellarium, you can download it from stellarium.org. There is also a mobile app version available. And I have been using this from last probably 15 years. This is my most favorite software. And you can see the night sky here, and you can see the moon. Right? Wait a second. Yeah. So you can see the moon here. So let me click on that, and I'll click on this button, which will center the object. And then just use my mouse scroll to zoom in on the moon. And then you can see the earth shine as well as the sunshine, both of them together. And then you can actually click on some of the craters of the moon and actually see the information about those craters. Let me try to see why it's not working now. Okay. Guys, anyone know why this is not working? But usually if I click here, it should actually show me the crater, name of the crater and all that stuff. Sudash, do you know? Okay, we can try to figure that out later. But there is an option using which we should be able to see the craters of the moon. Okay. Somehow it's not working today.
I think we need a plugin or something like that extra additionally, imported from website. I think then you will see all the craters.
No, actually, I had seen this today morning. It was working fine. And suddenly it has stopped. Anyway, that's fine. So I think, so now the moon is already completely covered by the clouds. So if I go back here, there is nothing to see on the live view. Also, Mars is also completely covered, but you can see here that Mars is just below the moon here. So if the sky is clear at your end, and if you're able to see the moon, then just below the moon, just below the moon, there is this red planet Mars, and you should all try to see this, because every day the moon changes its position. So let's say, for example, yesterday, if I just go to yesterday, moon was here. Let me just zoom out a little bit so that you can see a bit more clearly. So yeah, so yesterday moon was here at the same time. Day before yesterday, the moon was here. So now moon is slowly moving up, right? So today it is here. Tomorrow it will be here, and then day after tomorrow, much more up. So today, Mars is very close to moon, so it is very easy to spot Mars. So you should try to do that. And probably we will have one last glimpse of the moon before it disappears in the clouds again. Yeah, so you can see so many different craters of the moon. And one interesting thing is that during the crescent phase, you can see the craters better, because to see the craters better, what you need is the shadow, right? So here you can see that there is a shadow and there is a lit area which creates this kind of a 3D image. So if you see the moon during full moon day, you will not be able to see the craters properly, because on full moon day, if you are standing on the moon, sun will be on top of your head at the zenith. So you will not, the craters will not cast any shadows. And when there are no shadows, we will not see this kind of 3D effect in these craters. So crescent phase is good for watching seeing these craters. But each day, as the moon phase changes, you will be able to see different craters. Okay, so that's the thing. Okay, so now that we have seen the moon and also virtually explored Mars, I think we should also have a small introduction about the night sky. So now it's almost 8 o'clock, and we can see that some of the constellations are in the west, which are setting right now, and there are new constellations which are rising in the east, right? So all the stars also move from east to west. So if I just fast forward the time, you can see that all these stars are slowly moving from east to west, right? And one thing that you should note is that all the stars are actually revolving around one point, which is somewhere here, right? Which is near this particular star, which is a very important star in the sky. From South India, this star is not very bright, but as you go to northern latitudes, this also is can be easily seen through naked eye. And this star is the Polaris, or Dhruva Nakshatra. So all the stars, the whole sky seems to be revolving around this particular star. Now let me stop the time and go back to the current time. So currently, just if I just go back an hour, so I can see that there is Orion, which is setting in the sky right now, right? So Orion is setting in the sky. Orion has this belt, which is 3 stars in a line, and it's a very it's the most easily recognizable constellation in the sky. And also we have the brightest star, Sirius, which belongs to the constellation of Canis Major, which is a dog. So when we, usually when we explain, we say that, yeah, Orion is a hunter. So hunter should always have his dog, and Canis Major is his dog. And Sirius is called the dog star, right? And it belongs to this constellation, Canis Major. And also you can, this is easily seen in the sky even right now. So if your sky is clear in the west, you should be able to see this. And then we have the other constellations, like we have Gemini. So today, both Moon and Mars are in Gemini, and just above the Moon, you should be able to see two bright stars very close by. These are Castor and Pollux. So these are called the twins of the Gemini constellation. And then we have Cancer, which has very faint stars, so very difficult to see. Then we have, at the zenith, we have Leo. And if I just go back to east, so we have Leo, which is on top of our head right now. So if you just look up, you should be able to see the stars of Leo. And then we have Virgo, Libra, and so on. And another interesting thing is that there is another constellation which is rising here. So let me just start the constellation art to show you what it is. And slowly, let me fast forward the time a little bit. So here you can see a scorpion, right? So this is the Scorpius constellation. So there is a myth, or there is a story of Orion, that Orion was actually killed by Scorpion. And then here you can see that as the constellation of Orion sets here, the constellation of Scorpius starts rising here, right? So yeah, so there are a lot of very interesting stories. And then there is another major constellation that we should all know about, and that's the Ursa Major, right? So Ursa Major, also called as the Saptarshi Mandala. So there are 7 prominent stars here. So 1, 2, 3, 4, 5, 6, 7, and these are also known as the Saptarishis, right? This is also known as the Big Dipper, but here it's an inverted dipper, right? And then the 6th star. So if I count from here, 1, 2, 3, 4, 5, and 6. The 6th star is called Vasishtha. And if you look closely, and if you are in a dark sky, you should be able to see 2 stars very close by. So these are called Mizar and Alkar, or Vasishtha and Arundhati. So these are the Vasishtha and Arundhati stars, very famous stars in Indian mythology as well. So yeah, so let me switch off the constellation art, and you can see many other constellations which are very prominently visible in the night sky. Now, another important star is this star called Arcturus, which is called Swati in Indian culture. And there is Spica here. This is called Chitra. So there is Arcturus and Spica, Chitra, so which are very famous stars in Indian mythology as well. And if I fast forward the time a little bit, you can see something in the sky, right? So there is some band in the sky that is emerging, right? And here you can see the band of the Milky Way. So after midnight, you should be able to see the band of the Milky Way very, very clearly in the night sky. Now, the core of the Milky Way lies somewhere here. So the center of the Milky Way is somewhere in this area. And the brightest part of the Milky Way also will be in this particular area. So how do you find the Milky Way? So to find the Milky Way, first you have to find the Scorpius, the constellation of Scorpius. And constellation of Scorpius is very easy to recognize. So you can see that you can see this kind of J kind of shape, which is very prominent, and it actually looks like a scorpion in the sky. And then we have Sagittarius. So although Sagittarius is supposed to be an archer, it actually looks like a teapot, right? So you have the teapot here, and the spout of the teapot here, the handle over here, and the lid over here, right? So you have the teapot of Sagittarius and you have Scorpius, and between these two you can find the core of the Milky Way. And from the cities, Milky Way is very difficult to see, almost impossible. But if you go to a small village, or if you go to a place where there are no lights, then you should be able to see the Milky Way in the night. Okay, so I think for now this we can end this short introduction to the night sky, and then we can see if there are any questions. Over to you, Sudash.
Okay, so there is one question from YouTube which asks, what is the telescope setup that you have?
Okay, so yeah, I already showed my telescope setup. So maybe I can just stop sharing. Stop sharing.
Yeah, your video is filmed.
Okay, so my video is visible, right? So let me try to show my setup again. Wait a second. First, I have to see the video on my screen. Yeah, okay. So I have my setup here. I'll just show that to you. Just wait a second, sorry. Okay, so you can see my telescope here. So this is a Skywatcher 8-inch f4 telescope. So it's it has a primary mirror of 200 mm, which is over here. So maybe you can see the mirror over here, right? So that mirror, it is of 200 mm diameter, and focal length is 800 mm. So this is a 200 mm aperture, 800 mm focal length telescope by Skywatcher. And then I have a Canon 6D camera, which is connected to it. And then I have Skywatcher EQ6R Pro, Equatorial Mount. Yeah, so that's about it. So it's a 200 mm f4 telescope and Skywatcher EQ6R mount on a tripod with Canon 6D camera connected to it.
Okay.
What
awesome.
wavelength? What wavelength? So what is the context for that? What wavelength?
Not sure.
For the primary mirror,
I
I don't know what is the figure of the primary mirror. It could be probably 1/4 lambda by 1/4 lambda or something. I'm not sure. Okay. If there are no more questions, then probably we should move on to our next presenters, right?
Yeah, just actually one more question that we will answer actually. So can we see Andromeda Galaxy?
Oh yeah, we can definitely see Andromeda Galaxy even with our naked eyes if you are in a very dark location. So let me just show you once again by sharing my screen. I'll just take 30 seconds, not more than that. But first of all, I have to find the screen share button. Okay, so currently we have Ursa Major, right? Ursa Major, which is in the sky. So now we have to wait till Ursa Major goes down, and then Cassiopeia comes up. Okay, so Cassiopeia and Ursa Major are opposite to each other. So you have Polaris, On one side you have Ursa Major, and on the other side you have Cassiopeia. So when Ursa Major goes down, Cassiopeia comes up, and when Cassiopeia comes up, Andromeda also comes up. And then so you see this kind of M kind of shape, right? So you take this, use it as an arrow mark, go to this star, and then you find this star, and then you find this star, and then nearby you will see something very fuzzy. This is how it will look in the sky also. Actually, you will see something very fuzzy, and that is Andromeda Galaxy. So let me just bring that to the center and just zoom in a little bit. Yeah. Then here you have the Andromeda Galaxy. Right. So of course, it will not look so good to the naked eye or even through telescope. So through telescope, maybe you will see something like this. So in the telescope, you will see something like this. So you will have a bright core, and then you will have some fuzzy features around, and you will see the other galaxy which is close by also. So actually, if I just zoom in a little bit and show you more, there are 3 galaxies here. So there is Andromeda Galaxy here, and there is M32 over here. This is the second galaxy, and there is another third galaxy which is here, which is M110. So this M means actually Messier. So there is this guy named Messier who made a catalog of about 110 objects, yeah. So you have 3 objects out of those, and this big one is popularly known as the Andromeda Galaxy. So to the naked eye, it will to the naked eye, it will actually look like this. Yeah. And then through the telescope, it will kind of look like this. Okay. All right. That's it.
Okay. One last question from Rahul is how much this setup cost?
So the telescope was about 45,000. The mount was about 1.8 lakhs. The camera was about camera, you can get any DSLR camera, so that would work. So the telescope was 45K and the mount was 1.8 lakhs. But you don't really need this big setup for starting astronomy or for doing serious astronomy as well. You can have a small mount and DSLR and lens, and you can still do astrophotography. You can still see many things. Even with binoculars, you can see a lot of things. That's how I started this one. Okay, I think I have taken more time, so I should stop.
Okay, yeah. So we will move on to our next presenter. Our next presenter is Obuli Chandran from Coimbatore. Let's see what he has got to show us. Obuli, are you there?
Yeah. Yes, I can hear you. Thank you, Sudash. Hi, everybody. Today the sky is very bad. The cyclones have pushed the clouds in, and I'm not able to see. Of course, the moon is showing in and out, right, playing hide and seek. But once I cannot set it up to show you the moon. But maybe after this, I'll probably try to show the moon from where I am in Coimbatore. So what I thought I can explain you right now is my setup, the mount, which is similar to the one Kirti has got. But I'll try to sort of explain in detail about the basics of how this mount will work. Let me show my mount. Let me see if I can turn the camera and okay. So that is my setup. Is it visible, Sudash?
Yes, Obuli, visible.
Yeah, I'll just get in closer for a better view. So that is the mount with my telescope. So I have a AstroMaster 130 EQ f5 telescope. So, but of course, Kirti has explained about the telescope. Let me talk about the mount. So before we understand the mount, let me quickly give again, you get to see my face now. I'm sorry about it. So let me quickly go through the basics. So just like how you have latitudes and longitudes on Earth, right, to locate a specific spot. Let's say Coimbatore will have a specific a set of 2 numbers to indicate where it is in the sky. So similarly, we have a set of coordinates to locate an object in the sky. Of course, you can say up, down, left, right, but that doesn't tell clearly where an object is there, right? So like particularly, for example, you have to locate the object more precisely and track it for a long time. Coordinates are very important. So there are two sets of coordinates that you use to locate the objects in the sky. One simpler version of it is like how much above the horizon it is, and how much to the left or to the right of it is an object is to the north direction. Okay, you give them like altitude and azimuth as the set of names. Okay, altitude is how high is it above the horizon, and how much to the right or left of the north direction is the azimuth. Okay, the reason I'm talking to you about is there are two ways in which the mount can move. Okay, basically a mount is something that will help you move to a particular point and locate the object, right? A simpler version, is it only through a mount that you can locate an object in the sky? Not necessarily, because let's say you have a binocular, so it is bearable. It's not too heavy for you to need a mount to put it on and then look at the object. So you can hand carry it and look at, right? So whenever you want to move, let's say there is an object slightly above the horizon and you want to move to that object. So there are two ways in which you move. One is like you can imagine the vertical direction to be one axis, like let's say y-axis, and to the right or left, you can imagine it to be the x-axis. So let's say 4 units above and 3 units to the right. So you move sorry, I think I got muted. So you move in steps, like up, down, or left, right. To locate any object in the sky, normally you move up, down, or left, right. So there are two kinds of mounts that can help you locate the object. One is the kind of mount that will move up, down, and left and right. Okay, which is a typical mount that you will get called as the Azimuth Mount, where let's say you have the moon in the sky, so you have to move the telescope up and then move to the right or left depending on where the object is. Now, this kind of mount that I showed you before, it's called an equatorial mount, okay, which is similar to the one Kirti has got as well, which will track the object. You will have to move it in one direction. Once the other, remember I told you there are two axes, X and Y. One of the axes will be fixed, and you have to move the mount only in the other axis to track the object. So let me quickly show you the setup and explain. Okay, so I'm not sure if it is clear. Okay. Yeah, so here is the setup. You see a tripod.
Obali, we lost you.
Yes, I mean, I think the internet connection has been a problem. Okay, now can you see it? Is it visible?
Yeah, visible. Yeah, go ahead, please.
Yeah, so right now, I'm just moving around my mount so that you don't find it difficult. So this mount is the Skywatcher EQ6R Pro. As you can, I assume you can read it on the screen. Okay, so now this has got two axes. You can see the two green circles here. Okay, one here, another one here. Okay, so this moves in two ways. One is that I can move the mount in this direction, which is essentially moving in the west and east direction. Okay, and there is another way in which I can move the mount, which is in north-south direction. No. I'm sorry about it. I'm just so this way. So this is one way in which the mount moves, and the other way is the east-west. So this is the way in which the mount can move. This is north-south it can move, and this is east and west. So now, since it is like too chaotic, let me get back to my face, which is more or less better than showing the mount. So one of the things that you do, you can imagine the entire sky to be like a an outer circle and Earth being like an inner circle. Okay, so now you are standing on the Earth and looking up at the sky, and you see there are hundreds and thousands of stars. Of course, you cannot see it in a light polluted place, but imagine there are hundreds and thousands of stars, right? Now, like Kirti said, the moon was setting in the west, and all the objects, like, they rise in the east. If for an object to rise in the east and set in the west, the Earth has to spin from west to east, right? Something if spins from west to east, the things will appear to move from east to west in the sky. So that's exactly the way in which the Earth is spinning. But if you observe close enough, maybe using a Stellarium app, now you can see when you fast forward it, the stars are not going to move straight up. Okay, not just the star, even the sun or the moon, once they rise from the horizon, they are not going to move straight up. They are going to move at an angle. Okay, at some places it is more slanted. From where I am, for example, Coimbatore, it moves at an angle of about 11 degrees. None of these stars go straight up. So now all these stars, why do they go, at a slanted direction? Is because the Earth is tilted, right? So Earth is not, and all of you would know, Earth is tilted by about 23.5 degrees. So depending on where you are on Earth, okay, the way the stars move across the sky will be different. So now what this mount that I showed you does is that, it will, find the axis around which the entire sky spins. Like you can imagine it to be a balloon, okay, let's say, or a spinning top rather. Let's say I have a spinning top, and I mark a marker as a point on the top of the spinning top, like the center of the spinning top. And let's say I mark a few points using a marker around that point. Okay, when the spinning top spins, the center point which I've marked along the axis on which the spinning top spins, that will not move around. That will, stay in the same spot and spin. But all the other dots that I have marked around that central dot on the spinning top, it will be moving around, because as the top spins, it is going to move around, except the central dot, because it is on the axis of rotation itself. You can imagine the sky to be something like that. Okay, and from our sky, like Kirti showed the northern sky, you have Ursa Major, right? So just below that constellation, you have Ursa Minor, where we have this north star called as the Polaris, or the pole star. So now that pole star, okay, you can imagine that pole star to be the star, you can like the central dot on the spinning top. Okay, imagine the example I gave you, the central dot on the spinning top, that is the pole star that we see in the sky. So when the Earth spins, okay, that pole star is not going to move around, but everything around the pole star is going to move around, because the pole star is along the axis of rotation. Okay, you can imagine it like the imaginary line connecting the South Pole and North Pole, and it extends towards to the North Pole star. So that is how the sky moves. Okay, now in this mount that I showed you, in one of the axes, let me quickly show you again my setup. Just a minute. Okay, this particular setup, right? So this, you can see this reading, which is nothing but the local latitude. So now I've set it to my local latitude, which is 11 degrees. Okay, Coimbatore's latitude is roughly 11 degrees north of equator. Now this part, okay, has to be, this is parallel to the ground, and I've slightly tilted this entire part by about 11 degrees, which is where it will point to the North Star. So now this axis, this line is pointing directly to the northern direction at the pole star. So it's like, the spinning top's axis of rotation. So this axis is fixed towards the spinning top's axis of rotation. You can imagine it, compare it with that. Now this is going to the pole star. So on this side to the pole star, on the other side it will go to the southern skies. So now once this is fixed, this axis is fixed towards the pole star, now all you have to do is locate an object in the sky and just move this around towards west and east. You no longer have to move to the left of north or to the right of north like you would do in a typical Azimuth Mount, because one of the axes is fixed, which is straight along the axis of rotation. Now all you have to do is move to the west or to the east to keep an object in view. You don't have to keep, for example, in the other mounts that we talk, let's say after 5 or 10 minutes, the object would have moved clearly away because the Earth is spinning, right? So to bring the object back into the view, you will again have to move in steps. Like, for example, you have to move up and to the right. You have to keep moving up and to the right, up and to the right, because the objects are moving always in a slanted direction. You cannot take a curved path using the Azimuth Mount. But here, it's very easy because one of the axis is already fixed towards the pole star. So now you just have to move to the west or east. So the object will always be in the view. So this is the Equatorial Mount that is like preferred, or this is the most famous mount for astrophotographers as well. And again, some of the other things that I can show you is this is my telescope, AstroMaster 130 f5, which is the f ratio, and the focal length is 650 mm. And the primary lens, I can show you here. You can see that, I'm not sure if you can. Primary lens of the telescope, which is about 5 inches in diameter. Okay, the larger the primary lens, it can collect more light and create sharper images. I have connected a CCD camera here, okay, which is connected to my laptop here. And yes, I can use my software to capture. So I use the software.
Obali, I think we lost you again. Obali? Obali, you are there? Okay, I think we lost.
Sorry, Sudash. Yeah. I think I will. I mean, that is internet issue. But right now, I'll quickly share some of. I'm done with my whatever I had to say about my setup. Okay, that was my setup. Equatorial Mount, and I'll quickly share a few images I've taken through the setup, like 4 images. So just I can share, right, Sudash? I will be able to share, right?
Yeah. Are you logging to the laptop also, or how?
My laptop account only. I think Naveen has made me.
Oh yeah. You should be able to screen share. Yeah.
Yeah, I will do that right away. Just a minute. Yeah, I'm doing it right now. Just a minute. Okay, can you see my screen?
Yeah, we can see your screen. Yeah.
Yeah, so this is one of the images I shot using the EQR6R mount, which is from the Nilgiris Hills close to Coimbatore. It was in a place called Gudalur, close to the Mudumalai Tiger Reserve. So this is again, I remember in one of the presentations where Kirti was Sudash, or Kirti or Sudash, I don't know, who were explaining about the central part of the Milky Way galaxy, right? The brightest part of the Milky Way galaxy, and this is that part. So the central part is somewhere here, if I'm not wrong. So that's right. This is somewhere here, the Sagittarius thing, somewhere here or here. I don't know. I think it's here. So again, here you can see a few objects that has been captured. I have marked it here for clarity. I hope you can see it. Is it visible, Sudash? I have marked it.
Yeah, visible. M7, M6.
Yeah, so now here you see it's a Ptolemy cluster M7. Remember, Kirti was saying about Messier object, about 110 objects. Here are a few of those Messier objects that are captured in this image. You have Ptolemy cluster, you have Butterfly cluster, and you have Lagoon Nebula M8 and Trifid Nebula M20. I mean, it's a wide angle shot, so there is not finer details about it. And you can see this beautiful dust lanes, these are not clouds. It's not that I took this on a cloudy day. It's not a water vapor clouds. These are hydrogen and helium dust clouds. They are like part of the Milky Way galaxy. So this is one of the images that I took. Again, it's here is a close-up look of the Lagoon Nebula and the Trifid Nebula. I do not know if it has come up yet. Yeah. So yes. So
yeah, it has come up. Yeah, it has come up. You can explain now.
So this is one of the images, the central part of the Milky Way galaxy. I'll show you another image I took. Yeah, so this is another image I took, which is again, you can see the Milky Way dust lane here, Milky Way galaxy plane. Again, I have marked it for clarity. Again, you see Omega Centauri NGC 5139. Probably one of you can explain in detail about what Omega Centauri is. It's a cluster of stars. And then you have a Centaurus A, NGC 5128, again to the left of this. Again, I was able to take it from a dark sky. Again, it is the more close-up view of the cluster here. And you can see the Centaurus A here. It's not very clear, but you can see it. So probably some other experts will explain about these images. These are long exposure images, by the way. Each shot is about 120 seconds. And then I've taken 3 or 4 such images and I've stacked them together to get this output. So which is possible because of the tracking mount, which is able to track the objects for a longer time because it needs to collect more light to form more finer details. Again, it's another image I took of the moon using the same setup. Stack, you can see a lot of craters here. You can see the shadows in each of these craters. You can see the shadows of those craters falling in on the lighter part of it. And again, it's just unbelievable how much amount of craters are there. It's like, it looks like to the naked eye, it looks like very, uninteresting. I mean, moon is beautiful in the sky, but the surface itself is not very exciting to the naked eye. But the moment you look at that such finer details, a lot of things are more interesting about the moon. Again, it's another view of the same moon that I've taken. Yes, so I hope you learned something from my presentation. Thank you, Sudash, and I think I'm done with whatever I wanted to show.
Okay, awesome, Mobili. There is one question for you. Whether the Milky Way photo was taken by you using a DSLR and a tracker alone?
So that I didn't understand your question because I think
the Milky Way photo that you took was it?
No. Yes. DSLR and a tracker alone. Yeah.
Okay. All right.
Correct. I was using a Canon 7D camera with a 50mm prime lens. So yes, it was just a DSLR on this mount. Yes, DSLR with a 50mm prime lens.
Okay, we'll anyway have a Q&A session, so we'll take up the details, at that session. Okay, I think if Obali is done, then we can actually move to Ajay. Ajay, I think everybody is actually waiting. Even I am waiting for you to present.
Okay, Sudash, I am ready to show somewhat clear sky. A little bit clouds have come over here.
No, you have the envy of all over participants of India. Actually, we all having cloudy skies.
Thank you. Not much clarity over here, but I will be able to show some constellations with my minimal setup.
That will be awesome. And a few words of introduction about yours as well.
Oh, I'm an old astronomer. Been doing old amateur astronomer. Been doing it since more than 30 years now. And when I started, it used to be really difficult. Now with the digital cameras, it's become quite easy. And now today, for the first time, we are showing it live. So let's hope I am able to show something from my minimalistic setup. You can see behind me, there is a tripod. And on top of that tripod, I have fixed a cell phone. This particular cell phone is the Huawei P30. And this particular phone has a feature which it can build star trails inside. It can build star trails live. So that's a very interesting feature. And once I start up the phone as a host in this Zoom meeting, then you will be able to see the screen and the live view which is building up. So when I start the button for start trails, the view will be slightly dark. Then in the next frame, 1 or 2 stars will come. And in the subsequent frames, as it keeps on adding, you will see that these stars are becoming brighter. They are actually moving in the sky. And as the image builds up, you will be able to see some of the constellations on the screen. Well, at the moment, I am sitting on my terrace in Gurgaon, and Obuli was in Coimbatore, which is towards the south. And he was mentioning that the pole star over there is at 11 degrees from the horizon towards the north. I am sitting at 28 degrees latitude, and over here, the pole star is more than double what Obuli saw. So it's a different scene. I will quickly show what my phone can transmit. And then I also have a short star trail from San Francisco. My wife, Neelam, is a part of whatever I do in astrophotography. She's an air hostess, and she came back from San Francisco yesterday, and she has clicked some star trails from there. So quickly, in about 3 minutes or 4 minutes, I will show the view from latitude 37 degrees, where the North Pole is 37 degrees above the horizon. So now I'm going to shift to my cell phone, which is behind me, and start presenting from that phone. I will share the screen. I'm going to take off my earphone for about a minute and then come back and sit over here. Okay, everybody can see my screen and as well as hear me.
Yes, Ajay, both.
So my phone is pointed towards the western part of the sky. You can see some apartment buildings at the bottom, and you can also see the bright moon in the sky. I have a mouse with which I can control the phone. So you can see a cursor going around. And so let me show you what I can do with my phone. So I'm going to tilt this phone a little bit up. And you can see that the phone is trying to autofocus. So what I will do is click on the moon. Okay, I think I need to shift a little bit and come closer to the phone. So I need to touch on the moon, and it's going to take a while to focus. And then I'm going to lock the focus. And now you can see that the screen has gone very dark. I have gone wide angle. And now I'm going to start the star trails, go in the special section, and there is a item called light painting. I will click on it and click on the star trail option, and then click on the moon and wait for it to focus properly, and then lock the focus. And then I can go even wider and then start these star trails. Now, you can see that the first frame is dark, and slowly it starts to build up. And I'm going to wait for about a minute for the star trail. Now, what is happening over here? These are mini star trails. I am not going for hours to build up these star trails, but these are mini star trails just for about a minute or two. And what will happen is that these stars and Mars in the view will get brighter and brighter by each passing frame. You can see that below the circle is turning, exposure is happening one by one. And once 1 minute or a little more passes, I will show you the final image. So this is not a star trail where you will see a long trail of stars, but the sky will fill up with stars nevertheless. Okay, it's about a minute of building these mini star trails. And let me stop the exposure. And go to the image. So if I zoom in, you are able to see the moon, and right above it, you can see the twin stars of Gemini, Castor, and Pollux. Now, at the moment, the sky is getting covered with clouds, and Mars is not visible in the image. But if I shift to other part of the image, probably you'll be able to see some other stars. Okay, here is one star, and you can see that it is slightly elongated, means it has trailed for 1 minute. You can also see the halo of the moon, and this halo is occurring because there are clouds in the thin clouds in the sky. And let me zoom out a little bit, and you can see that the halo is towards the left only. So this is like a rainbow around the moon. Okay, so I'm checking which part of the sky is clear, and then I will point my camera to it. Well, it looks like the eastern sky is clear. I can see Arcturus right on top. So I'm going to switch off these lights which are illuminating me, and then I will move. So I'm taking off my microphone for a bit. Okay, I'm back in front of the camera, but you cannot see me now because it's I have switched off the ambient lights which were there. I'm going to shift the direction of my phone. And you will be able to see as I shift. So now my phone camera is pointing towards the east, and the focus is still locked. Right on top, you can see the star Arcturus, although not many other stars are visible. So let me go on the other side. Let me see if the mouse, okay, it seems to be working. I'll shift to wide angle and then start to make the star trail. So the first frame will be very dark, and the next frame, you will see some clouds, and each subsequent frame will have brighter and brighter stars. Unfortunately, in the sky, there's a lot of cloud and just a couple of stars. And the star Arcturus is right over here. Let me show you with the mouse. So you can see Arcturus over here. And as the trails are built up, you can see that Arcturus is getting brighter and brighter. Also, you might be able to discern that some clouds are moving over Arcturus. So I'm going to stop in about a minute or a little more than that, and then zoom into the picture and see if any other star has been captured. By the way, this method, which I'm using in my Huawei, is probably available in many other phones. And it's a fantastic, it works beautifully when you are at dark places, hill stations or deserts. In Delhi, well, you can't see many stars, but this is a method which works very beautifully in dark places. Okay, so I'm going to stop the building up star trails and show you what I have captured. So you can see that Arcturus has trailed quite a bit. So this is a sort of mini star trail to display the constellations. Well, till the evening it was quite clear, but at the moment there are thin clouds all over the place. And I'm going to shift to the presentation that I had lined up, and it will take about 5 minutes to show you. But first I will take off my microphone and switch on the lights that are there so you can see me. Sudash, can you report if you can still hear me?
Yeah, Ajay, you can. Yeah, you are very much audible.
Thank you. And my screen is also visible, which the slide that I put up.
Yes, visible actually. A
Thank you.
beautiful sea or soundscape visible.
Okay, this is the San Francisco Bay. It's a place very close to the airport, not in the main city. My wife was there yesterday, came back yesterday after a long flight, and she had gone via Bangalore, and she had 3 nights over there, and she was able to utilize 2 of them very nicely for astrophotography. Now, in this image, what I actually want to show, what I actually want to narrate is that you can see the railing of the hotel where she was in the San Francisco Bay. There is a bridge far in the lighted horizon. You can't see it very nicely, but it's there. And in the sky, you can see very few stars. So this is an exposure which is about less than a second, and not many stars have captured in the image, but you can see on the left that many such images she has captured, Neelam. And now I am using a software called the Star Stacks, and it is a free software. And I have converted all my raw images into JPEG and loaded into the Star Stack software. And when I press the button to blend, start processing, what you will see is that the star trails start to build up and the sky starts to fill up with stars. Now, these stars were there already. So if I stop now, this is a fantastic image where stars are pinpoint. But if I start the processing again, you can also build an entire set of images into a perfect star trail. Now, in this image, you can see the Cassiopeia constellation, which Kirti has shown in Stellarium, is lying right at the just above the horizon, and the pole star is over here. You will see that all the stars will trail, but the pole star will remain at its position. On the right, somewhere on the right, there's a bright star which I cannot see on my screen because there's a whole lot of videos going on. That's Vega. Now, I always get surprised, very fascinated by looking at Cassiopeia hugging the horizon, and it is actually at the lower transit. This is the pole star, and just below it, the constellation of Cassiopeia is there. So I'm always surprised because in India, you're never able to see this view. So the pole star over here is at 37 degrees above the horizon because we are at a latitude of 37 degrees at San Francisco, and these are polar star trails forming. So this is what surprises me. So this is a fantastic thing. When you are clicking in the city, you can click short exposures, but then stars don't show up. So what do? So you click about 10 to 12 exposures rapidly, one after each other, using the same exposures of 1 second or less, and then you blend them together into mini star trails, like I just did in Star Stacks. At the end, I want to show you one video which is also very surprising. This is a video which I clicked from the window of a plane flying from New Delhi to New York. And in the first image that you see over here, you can see the engine of the 777 aircraft. And this bright line is the border between India and Pakistan. So on the left is India, and on the right is Pakistan. So one people, one sky, divided by a big border. So let me start this video. And the interesting part, okay, I need to reduce the volume of the video. How do I do that?
Ajay, we can't see the video.
You can't see the video?
No.
Okay, I'm so sorry. Now can you see the video?
Yeah, now we can see the video.
Okay, let me repeat. This is a video from New Delhi to New York. And somebody has to tell me how to reduce the volume of this video. Okay, what I will do, I'll go to volume mixer. Open volume mixer. And okay, I found it. So if somebody finds the volume still too high, please let me know and I will reduce it further. So this is India-Pakistan border and we are crossing. So the plane is flying to New York. Sudash, am I audible?
You're audible, but the music is not.
Oh, okay. I think we can let the music be. If I'm audible, that's okay. Now,
Okay.
in the end, when New York is approaching, this was a high latitude flight. That means it went up to a latitude of about 70 degrees. And then it started to climb down southwards. So the direction before landing into New York was southwest. And I was sitting on the left side window and Venus was visible very brightly. Now, we were landing into New York at sunrise time. So you can see Orion over here hugging the horizon. You can also see Sirius very next to the horizon. And moonlight is shining from top. Now, at the left side, you can see the bright Venus. Now, usually when we see Venus in the morning, it rises very quickly and it turns to day. Now, what is happening in this video? This video, from this time to the end, the shooting time was about 3 hours. 3 hours long video, shortened. But Venus is not rising at all. Venus is just not rising. It remains there in the sky for those 3 hours. You see, it is turning daytime very slowly. You can see the dawn. That's because the plane was at a very high latitude. Now, this will take some explaining, but in short, basically, since we were traveling southwestward, Venus was rising so slowly over a period of more than 3 hours. Of course, you can see it rising, but it happens very rapidly. Well, this is all I had lined up. I did line up the Ursa Major, but it's turned cloudy over here. So unfortunately, I'm not able to show it. So back to you, Sudash. If there are any questions,
Okay,
I'll be happy.
those are awesome, actually. Yeah. Let us see if there is one question is Aurora Borealis at 1:36 in the video. Is it so?
Yeah, there was a little air glow. So it was not a full-fledged aurora, but there was a little air glow in the sky.
Okay, all right then. So I think those are the questions for you. There are some questions which we will take up in the Q&A section in the last.
Sudash, do I have another minute to show aurora?
Yeah, why not actually, please.
Okay. So here is a video recently which I clicked on a flight from San Francisco to Bangalore, which Neelam clicked. And you can see spectacular auroras. You can see Pleiades and Hyades in the sky. This is all from a plane window.
And very, very clearly visible are Pleiades and the Hyades cluster of Taurus.
That's right.
Awesome. Fantastic. Okay. Okay, and what equipment do you use?
Oh, for this plane window shooting, I usually have a very lightweight tripod. In fact, this is the same tripod which I'm using over here. This tripod weighs about 1.5 kgs. And I use a very fast lens, 20 mm, f1.4, and an ISO of about 3200 or 6400, so that the exposures come to about a second or so. If the exposures are longer, then the vibration from the aircraft affects it. So that's my setup.
By the way, folks, Neelam and Ajay has given a 1.5 to 2 hour talk on how to take such photographs and videos from an airplane window. It is there available in BA's YouTube channel. Please go ahead and actually search for it and look for it. It is an amazing treasure. After that, you will say that my flights have never been the same. Okay, I think apart from that, if there are no more questions, then we will move on. Thank you, Ajay.
Thank you, Sudash.
Awesome. Yeah. Let's see. Mihir, are you there?
Yeah, I'm here. Can you guys hear me?
Yeah, we can hear you actually. Okay, so
think yeah. Hey, hi guys. So it's actually raining here. I was about to show you a proper setup, like a portable astronomy setup, in between what Ajay showed and what Kirti and I think Obuli has mentioned. So I have a smaller version of their setups. It's called Ioptron Sky Guider Pro. which tracks the sky in the same way, but it's not a huge setup, so you can carry it anywhere. You can place it on tripod. So let me just switch to the video here, and I can show you the setup, maybe explain some features.
Okay, quickly, Mihir is from Kolhapur.
Okay. Can you guys see the setup now? Is it visible?
Not yet.
Okay, I guess. Can you just quickly spin? Yeah, cool. Yeah. So this is a Ioptron Sky Guider Pro, and you can see a small camera, like a DSLR attached to that. This is a portable rig. What we are talking about here, it's about 1 kg, and it's attached on a small photographic tripod. Like, we just move the camera here, you can see the camera there. Yeah. So that's the setup I am having. I just recently purchased this tracker, and it has some features like from the bigger trackers you have seen, but one of the major features, who is just starting the astrophotography, or who is just going for the this kind of setup, or just want to start like astrophotography, this is the beginner setup I have. So there are some features. Let me just show you here. You can see I've set it up to the my altitude, like as Obili has mentioned. I'm at 16.7 here. And the second part would be there are a few controls here. You can see there are different modes for sun.
We can't hear you properly, Mihir. Mihir, we can't hear you properly.
Okay. Okay, just let me switch to the mobile audio.
Yeah.
Let me switch to the mobile audio.
Okay.
Is it better now? Hello.
There is echo, so you'll have to also.
Is it better, guys?
Yeah. Now it's better.
Hello.
Yeah, now it's better. Can you hear us?
Yeah, I can hear you guys. Is it better now?
Yeah, it's okay.
Okay, go ahead. So let me just show you the modes. Like, let me switch on the tracker. So there are small different modes, like the side real or the tracking speeds of Earth, like the tracking rate are different for the sun, the moon, and the night sky. So these are different modes here. You can just operate it. And if you are in the southern hemisphere, you can set it to southern hemisphere. There is basically what, as Obili mentioned, there is a polar master, like a guide scope here, which you can see and polar align it with. So I think I've aligned it to whatever the best I can, just to mimic the whole thing. So this is a normal scope. It doesn't have an ipolar scope actually. I think someone just posted that. And I've attached a small ball head there. I've been using this old 135mm Nikon D5600, and as you can see, it has attached to my laptop for the capturing. Let me just hi. So let me just go ahead and share a few photos I've taken with the camera and this setup recently, because it's been raining. I cannot able to show you some pictures, like live pictures what Ajay did, but let me just go ahead and share my screen, and you can see some pictures. Yeah. Is it visible, guys?
Yeah, visible.
Okay, great. So this is a single exposure image I've taken with the mount tracking at. I've used a D5600 and a 35mm lens, which is a 1.8 lens, and this is at 1600 ISO and 30 seconds of exposure. I haven't used any external device to capture it, just intervalometer using the camera. I'll show you the tool who have done it. The next image I have is probably. Yeah, this is the processed image. I have stacked about 30 images of the same to increase the signal to noise ratio, and you can see how beautifully the details have come out for the Milky Way region. This is the core part what Kirti and I guess Obili has explained. So you can see Rho Fuji complex over here, the dark nebulas and the main Milky Way core with Trafad and Lagoon nebulas over here, the hint of it. This is a wide angle view, but since when you capture this much data, you can see how the data has come out so well. So let me just go ahead and share like what a single like before stacking, how the image looks like. So this is the TIFF image. You can see it's not very bright. It's washed out image, as you can see. But like it has like once this is a TIFF file basically, and once you process it in the Photoshop or after the Lightroom, you get to see the this image. And okay, let me just screen maybe. Okay, yeah. Is it visible now?
Yes, visible.
Yeah. So this is the astrophotography tool which I use to capture. I've just connected my camera as I showed you from USB to this part. The camera is connected, and I can start shooting the different exposures and the frames we need to process the images. So there are different kind of frames you can go for, like flats, bias, darks, which will help you to get the better image and reduce the noise. Like I won't go into the details. I think we have different great sessions from many people, but this is the tool we use. And the main purpose like behind using this tool, or basically to use the tool, is to reduce the shake from the camera, because once you have the tracker running, if you go for the camera and the camera shakes, you will get, yeah.
You have to change the share to your screen. We can only see the Milky Way image.
Is it not? I thought it's visible. Okay. Okay. I thought I was sharing actually. Okay. Yeah. Maybe. Okay. Cool. Is
Now.
it visible? Yeah. Yeah. Okay. So this is the tool I'm sharing. This is the basically. So you can see some of the like the camera is connected here, and you can take different points of like as I explained, the flats, images, and you can write some scripts and take the images from there. And yeah, that's about it. I guess that's the portable setup. You can just go ahead and start the imaging if you're interested, and you can just carry this anywhere. That's the best thing I can do. Just carry it in a backpack, I guess. Yeah, over to you, Sudash. I think that's about it.
Okay, awesome here. Any other photos that you want to share that you have taken, or okay?
I think we can go for Q&A, but yeah.
Okay, all right.
Yeah.
Okay, you, Ganesh, if you are ready, you can take over.
Okay. So, am I audible?
Yeah, Ganesh, you are audible actually. Let me pin you as well actually. Wait.
Okay. Okay. Hello, everybody. I'm Ganesh, and I'm from Coimbatore. I started astrophotography just a year back. I'm still a newbie, so I'm just I just set up a rooftop astrophotography setup. So what I will do today is I'll explain the fundamentals of astrophotography, or the process flow that I use. So I'll just share my screen and start. So is the screen visible, like the presentation mode?
Yeah, Ganesh, it is in presentation mode. Yeah.
Okay. So this is what I want to cover, basically the astrophotography basics. And then there are two parts in astrophotography. One is the image acquisition part and the image processing part. Then I'll finish it with the, some of my images that I took with this setup of mine. So the basics of astrophotography is that we are trying to shoot objects that are very small. They can be a few arc minutes to a few tens of arc minutes in the sky that are very far small galaxies or nebulae. The light, the photo travel from these objects.
Ganesh, your voice is breaking a lot.
Very, very dim. Oh, okay. Oh, just a moment. Okay. Is it better now or?
Yeah, it is better now. Yeah.
Okay. So now, if we have to photograph the small objects which are very far and which are very dim, we require optics that can magnify the smallest of the objects, hardware that can accurately track the objects as they move across the sky. You can see as the Earth rotates, none of the objects are going to be in the same position. If I take a constellation like Orion, if I'm going to shoot it over a period of even 5 minutes, it would have moved from one place to another. So we need to have some sort of hardware that can track the object in the sky and keep it in the same position in your camera's sensor. And then we need a camera with the which can support very long exposure times, sometimes in tens of seconds to even sometimes tens of minutes, with very less noise. And finally, we need software that can bring out all the details from the small signals that we acquired from the camera. This is the basics of astrophotography. Now, as I said, there are two parts to astrophotography. One is the image acquisition part, and the second is the image processing part. And in image acquisition, we again have hardware and software. So for hardware, I'm already in my terrace near my setup. So I will just show you the setup live. Though I had put some slides because it was raining here. I didn't know if I could even come and open up the system. So this is how my setup is. My telescope and the mount are all anchored to the ground permanently so that I don't have to move them. Earlier, I used to have a tripod. So every time I have to come and set up, I used to carry this tripod, and then the mount and counterweights, everything put together weighs close to 50 kilos. So I had to break them apart and then bring them into 3 or 4 rounds. And then setting up used to take an hour. So I made a system like this where everything I set permanently, and then I made a small movable shelter, which I just move and cover it. So it is easy for me right now. I just come, open everything, move the shelter away, and then start shooting. Okay. So now let me stop this screen share, and I will take the camera out. So this is my setup. So you can see this is the pier, which is called, yeah.
May I request you to have as least movement as possible, please?
Yeah, I'm holding the camera on hand, so please bear with me. Is it okay now?
Yeah, thank you. Yeah, people will be able to see more if the camera is steady. Thank you.
Yeah,
I'm
yeah.
sorry for
I will.
sorry for
No,
the
I
interruption.
was walking, so it's fine. I'll be careful. Don't worry. So this is the pier, and then if you come up, you have the mount. This is again the same mount that Obli had and Kirti had. It's an EQ6 R Pro, which is a equatorial mount. And then on the top, you can see. I go a little closer. So this one is the main telescope, the big one. It's a William Optics GT81. It's an APO triplet refractor telescope. And then I have this is the main camera. What you're seeing here is a ZWO 2600 MC Pro. This camera is can cool down to 35 degrees below ambient, and because of that, what happens is the reason why we use cooled camera is when we keep the sensor temperature very low, like 0 degrees or minus 10 degrees or minus 15 degrees, the noise coming from the sensor will be very low. As we are collecting very faint light, we do not want much noise to distort the actual light collected. So a cooled camera is much better and useful. And then what we have here is, this one is an autofocuser. This is a ZWO autofocuser. What this does is I have a acquisition software that can control the focusing mechanism of the telescope and get pinpoint focus. And then on the top, you have the smaller telescope. This is a 50 mm 50 mm guide scope we call. And you have a small camera here. It is a ZWO 224. It's a planetary and guide camera. So what this does is, I think I'm done with showing you the setup. So I'll get back to the PPT. Okay. So now, so the main telescope is a APO triplet refractor with a 480 millimeter focal length with a f by 5.9 focal ratio. And then I have a 0.8x focal reducer and field flattener, which also reduces the focal length to 384 mm and focal ratio to 4.7. That means it becomes a little faster. At a lower, for smaller exposure times, I can get better light output. And then the main camera, as I explained, it's a 26 megapixel CMOS APS-C sensor. Which can cool down to minus 35 degrees below ambient. And then there's an autofocuser. And this is the mount that I was saying. It can take a payload of 20 kilos that it can take. Put together, the equipment weight can be up to 20 kilos. And then this is a guide scope. So what a guide scope does is the equatorial mount tracks objects and keeps them in the same position in the camera's sensor. Up to even, let's say 1 minute. If I have an exposure time of 1 minute, the object may stay in the exact same place and it may drift by maybe a few pixels. When I have a guide camera, the guide camera keeps tracking stars, and when the stars start drifting, it will issue a corrective signal to the mount, so that the mount will also add this corrective signal and bring back the stars into the same position. So because of this, we can do very long exposures. I can do like 5 minutes or 10 minutes or even 20 minutes without any trail, or even the stars will be pinpoint round. So that was the hardware part. Then we have the software. Now, when I'm going to acquire image, there are so many things I need to do. One is I need to do polar alignment, and then I need to point the telescope to any object that we desire. And then I need to focus then I need to be able to set some exposure times. Say I decide an object that I want to expose for 2 hours. Then I will set with 3 minutes of exposure time per frame. Then I will automatically create a sequence which will give me like 40 exposures of 3 minutes each. And for all these, I use a software called Nina, Nina. So this does everything for me. So once I initiate a sequence, the software automatically finds the object. It does something called plate solving, so that it will find exactly if the object is in the center of the screen. If it is not, it will issue corrective signals and correct the telescope to exactly point to the object, and then it will start shooting. And then it will save all the image files. And then once the acquisition is complete, I can take the image files and go into the signal processing stage. So if you see, this is the result of image acquisition. This is the first one is a single exposure of 180 seconds of Bodes and Cigar galaxies. And then the second is again a 3-minute exposure of Rosat Nebula. If you see these pictures, the galaxy is, you cannot see too much of details of the galaxy, or you really do not see any nebula here. But actually the signal is there. It is very faint. And for me to bring that out, I need to stack multiple exposures of these pictures and then bring out the result. So that is where the processing comes in. Okay. So image processing. What are the things we do in image processing? Is the first thing is calibration. So when we acquire an image from the camera, there is going to be definitely, even though I have a cooled camera, there is still going to be noise in the sensor. And then there could be dust in the optics. The dust can introduce some small donut sort of black objects on the exposure, and the optics itself can have vignetting. So on the corners it will be very dark, in the center it will be bright. So all these aberrations can be compensated by using calibration frames. What we do is we close the telescope completely, make it dark, and then shoot so many images from the sensor. So those images will represent only noise. And then we put some white cloth in front of the telescope and do an exposure where light will pass through. It will also magnify, or it will show only those aberrations like dust or vignetting, all that. Now what I need to do is I'll take these calibration frames and I'll subtract these from the actual image to get rid of these distortions. So that is called calibration. The next is stacking. Stacking is where we put multiple frames of this, like if I took then post-processing. So
Ganesh, I think we lost you. Hello?
hello, is it? I don't know. Somehow it went into mute.
Okay. Okay. Now, can you speak now?
Yeah. Is it clear now?
Yeah. It's clear. It's clear. Yeah.
Okay. So then post-processing is where we do things like fixing histogram, brightness, contrast, color correction, and maybe sometimes even light pollution can bring in some gradients, light gradients in the image. Those things can be fixed. There are so many things that you can do to get rid of undesired results in the picture, and then bring out the actual object. So now,
Ganesh, you can show the the audience the images. They are probably waiting a lot.
no.
When you'll be showing those images.
Oh, hold on. Yeah. So this is the processing flow. This is how the first image looks like, single exposure. Then when I add 90 of the frames, you can see the nebula right now. But you can see there is a gradient, right? On the left, top left corner, it is dark, and the bottom right corner, it is bright. So I can extract the gradient, background extraction is called. And then you subtract it from the original image, you get rid of the gradient. And then you do color corrections and bring down histogram, crop it, and then you get the final image. So this is the processing part. Now I'll show some of the images that I took. This is the Rosat Nebula. Rosat Nebula is situated 5,200 light years from the Earth. It has a size of 65 light years. And this image has a total integration time of 4 hours and 30 minutes. So I took 90 frames of 3 minutes each, and then I had to integrate. And then this is the Board and Cigar galaxies. These are situated at a distance of about 11.5 million light years from the Earth. The Board galaxy is 45,000 light years wide, and the Cigar galaxy is 18,500 light years wide. And this for this, the total integration time was 72 minutes with 24 frames of 3 minutes each. And this is the Orion Nebula. Orion is the brightest nebula that you can watch with your naked eyes. It's very close to Earth. It's 1,350 light years. And then this one I took with an integration time of 60 minutes, 30 of 2 minutes. And then this is a string of galaxies. You can see a lot of galaxies. If you sit and count, you could even count 50 or 60 galaxies here. It's called a Markarian chain. You can see that it forms a chain. On the left side, you see one bright galaxy, and on the right side, you see a necklace sort of arrangement of galaxies. So this Markarian chain is situated at a distance of 35 million light years, and this one took I took 30 minutes of integration time. The reason why I could manage this with 30 minutes of integration was I took this in a dark site from Coorg. So when you don't have light pollution, you can easily collect more light, and you can manage with the shorter exposure time. So this one is 30 frames of sorry, it's actually 30. The integration time is 60 minutes, 30 frames of 120 seconds. So that's all I have. I'll stop sharing. Yeah, so I think I'm
Awesome,
done
Ganesh.
with my.
Fantastic. Okay. So let me remove the pin on yours.
Yes.
Okay. Then Likita, if we can actually, ask the questions on, we have received over the forum in both YouTube and, Zoom. One of us can actually answer those questions.
Yes, sir. So one of the questions was basically for Kirti, sir, but any one of you can take up, I guess. What are the filters you use while doing astrophotography?
The filters?
Yeah, what are the filters?
Okay, I use a Optolong L Pro. L Pro filter, and so when I'm shooting from my terrace, I use the L Pro filter for getting rid of the light pollution here. But when I was shooting in Coorg, I didn't use any filters.
I would like to answer.
Yes, sir.
For my landscape photographs, I like to use a star filter, star burst filter, which actually produces spikes in the stars. So brighter stars, bigger spikes, smaller stars, smaller spikes. I also like to use a fog filter. So fog filter, when you're photographing at a dark location and there are so many stars in the sky, all the stars look the same. So if there is a bright star and if there are fainter stars, they all look the same. So how to convey in a night landscape, how to convey which star is brighter? So the size of the brighter stars has to translate into bigger diameter. So how do you do that? Because if you have focused accurately, all the stars have same size on the sensor. So if you use a star burst filter, or if you use a fog filter, then the brighter stars turn out to be bigger. And in the final image, they appear to be brighter simply because their size is more. So other than that, the filter that Ganesh mentioned is very useful for reducing the sky pollution. And most of the light in the sky in the cities is because of sodium vapor lamps, and the light pollution reduction filter that he mentioned is able to cut off that light, and your deep sky images are brighter and better and more colorful. Thank you.
Okay. Anyone else would like to take up the question?
Just add one more point. So as Ganesh and Ajay already mentioned, and Ajay really mentioned some interesting filters which I have never used, but I would definitely want to use them once. But my camera, I have, instead of adding a new filter, I have removed a filter, which means it's a modified camera. So I have a old Canon 450D in which the filter has been removed, which actually cuts the IR frequencies. So basically, this is needed to make sure that we get all the red nebulosity. So what happens is, in a stock camera, because of the inbuilt filter, the red H alpha nebulosity is not very well captured. But by removing that, we can get good H alpha images. Apart from that, I also use sometimes a H alpha narrowband filter. So because in the cities, it's very light polluted and it's very difficult to capture any data. So by using a narrowband filter, which will only allow a particular wavelength of light to fall on the camera sensor, we can make sure that this light pollution has lesser effect than just capturing without any filters. Thanks.
Okay, I want to add something. I was going to mention about the UV filter, which usually people have in front of their camera lenses. And as it happens that there has a question just appeared, what happens if we remove the UV filter also? Will it be useful for astro? Well, you must remove the UV filter because it causes internal reflections. It's a plain glass, and if you point your camera towards the moon, you will capture the moon, but you will also capture an internal reflection. The moon will have a crescent opposite shape. So most of the times people discover something in the sky, but it just happens to be a halo of the bright object nearby. And that's because you have not removed your UV filter. Thank you.
Okay, so I think that answered the question. Next question we had was, has anyone spotted the great spot of Jupiter using a reflector?
I can take up that question. Yes, it's very prominent. Yes. So one thing about reflectors is that the reflectors have spider. So because of the spider, when you see bright objects like Jupiter, you get kind of a spiky thing around Jupiter as well. So I have a modified reflector with 3 spikes instead of 4 spikes. So that kind of reduces these spiky effect. If you have if you have a long focal length reflector, you can definitely see. And also, if you use more magnification, actually, you can definitely see the great red spot very easily. Tracking definitely helps. And good collimation definitely is a must if you want to see the great red spot. And also Jupiter must be a little bit high in the sky. If it is very close to the horizon, also it becomes very difficult. But if it is over, let's say 30 or 40 degrees altitude, and if you have good collimation, and if you're using a good amount of magnification, and also if you are using a tracking mount. And one more thing is that Jupiter keeps rotating, right? So it rotates at the speed of one rotation per almost 10 hours. So every 10 hours it keeps rotating. So you should know at what time Jupiter, the red spot is visible. And if you see at that time, you will be able to see the great red spot.
To check the time when great red spot is in front of you, there are two websites that you can visit. One is Project Pluto, and the other one is skyandtelescope.com. These two sites will let you know the time that the great red spot is in front and visible from the Earth. You can also, great red spot is easily visible. You can also go for smaller oval BA, which is called. It is like a red spot junior. So apart from the great red spot, you can also see the red spot junior. Kirti mentioned that the collimation has to be spot on, high magnification, all those are there. But yes, you can definitely see these two spots. Thank you.
So, sir, can I now ask my doubt?
Yeah, Aradhya, go ahead. Yeah.
Sir, I have a Celestron Astromaster 70 mm telescope. So, how can I use my DSLR Canon 1300D in it to click photographs?
Should I answer that?
Yes, sir.
Okay, it will be far more beneficial if you use your DSLR on a tripod and shoot 30-second exposures. This may sound counterproductive, that I am not advising you to attach your DSLR with your small 70 mm telescope, the Astromaster. That's because the mount is more important in astrophotography. And the mount that you're mentioning is simply not capable enough to hold a DSLR as well as the telescope and be steady. I would suggest that you point your telescope towards the moon and hold a cell phone behind the eyepiece. So simply.
I simply do that only.
Oh yeah, you're already aware of that. Okay.
Yes.
So let me add to that. You can purchase a small cell phone adapter which will hook up to the eyepiece, any eyepiece that you have, and it can hold a cell phone, any kind of cell phone, and your views will be much more steady. So unfortunately, the question that you have asked, we have tried to dissuade you from attaching a heavy DSLR to your Astromaster 70 mm.
Sir, and what app do you recommend for photo stacking and exposure?
Say again, what app?
What app do you recommend for photo stacking and exposure?
Two completely different questions.
Yeah,
I would use, well, there are a lot of software that you can use for stacking. On the top of my head, Images Plus, PixInsight, but those are really far. Really my recommendation is to put your DSLR on a tripod and go to a dark place far away from cities and shoot a 30-second exposure. You will get a far better picture than connecting your camera to a telescope.
yeah, true that actually. So that will be the suggestion for Aaron. Okay, we
Yeah,
can
but
move on to the
just
next question, Likita.
but,
Sorry,
but
Kiran,
just
sorry.
one last comment. One last
Sorry.
comment. So, I mean, although it's not recommended because it's, I mean, you need to have a good mount and you need to have a good focuser which can take the weight of DSLR. But if you just want to know how the DSLR is actually connected, just for the information, so you have the, I mean, this is how I connected my telescope. I just wanted to show that. So this is the camera with the lens removed. So once the lens is removed, you have a T-ring. So this T-ring, so it's different for different camera companies. So for different mounts. So for example, for Canon, this will be different, and for Nikon, this will be different on one side. The other side will be common. So this is called a T-ring. So you get a T-ring, you attach the T-ring to the camera, and then you get an adapter. This is not an adapter. This is actually a coma corrector, but you get a similar adapter, which you would connect in front of the T-ring, and then you would insert this whole thing in the eyepiece, in the focuser. Instead of the eyepiece, you would put this whole setup in the place of the eyepiece. So although, yeah, I mean, for Astromaster 70, the weight may be too much, and also the telescope would shake and all that. So if you have a better telescope and a better setup, this is how you would connect the DSLR. Thanks.
Thank you, Kirti.
I have a doubt, sir.
Yes, sir.
Yeah. So you're talking about the calibration frames, right? When taking the flat frames to reduce the vignetting, right? Is there like any easy method to do that? Because it's like we need like a nice and flat surface, right? And white color. Is there like easy way to do it?
Yeah. So one of the ways to do is you can put a white cloth. You can fold it into multiple, make it thick, and just cover the telescope, and then put a light source in front of the telescope. It could be, you can even point it towards your inside tube light or some LED lights or something. So it uniformly illuminates. And then you take pictures and then see the histogram. Histogram should be like half to 1/3.
Okay.
This is the way you need to take the flux. Now, what I do is I use Nina itself. What Nina does is all I need to do is just cover it all with a cloth and then point it towards the light source. And then Nina does automatically takes multiple exposures and then checks the histogram and then automatically adjusts the exposure and gets the flat correctly.
Okay, sir.
But if you're manually doing, you set your exposure time in such a way that your histogram is half or 1/3 between that.
Okay. Yeah, and I have one more question. Like in the DSLR, when we are modifying it, you told us we can remove the UV filter also, right? Because like there are two major filters for the sensor, which is the IR and then the UV. But if we remove the UV, like I'm not talking about the APO refractors, but if you're using like say normal lenses, they're not that great at focusing the blue light, like especially the UV light, right? So if I remove that, will there be any problems with like the star halos or something?
I think I haven't done any DSLR modification, so maybe Kirti can answer on that. Take the question.
Actually, the modification that I have done is I have removed the stock filter and I have put a replacement filter, which will, I think, which will still cut the UV and also cut the IR, but only allow the H alpha to pass through. But maybe Ajay has more information about this.
Okay.
I was actually answering a question on the chat. Could you please repeat the question?
Yeah, basically, the DSLR, if we remove the UV filter, since we are not using any APO refractors that can easily focus all the colors of light, like the normal stock lenses or zoom lenses, they are not that great at focusing the blue light, right? So is it fine if we leave the UV filter? Because if if we remove it, will there be any halos like blue color around the bright stars or anything?
Do you mean the UV filter which is in front of the lens?
Yeah, no, in front of the sensor.
Usually we remove the IR cutoff filter.
Yeah.
Now UV is ultraviolet, which you are mentioning. We don't remove that. What we do remove is the IR cutoff filter. Let me explain what happens. The sensor is able to capture the visible light, which is visible to the human eye. It can also capture the infrared. The sensor is capable of detecting infrared light. But if it starts to detect infrared light, the daylight photographs every day, if whatever you click, will not look as your eye sees them. So what they do, the camera manufacturer, what they do is they introduce a filter which restricts the infrared from reaching the sensor. And the pink nebulae in the sky are emitting in the infrared H alpha wavelength, which is just a little bit out of the range of our eyes. But if we remove the IR cutoff filter and introduce a filter which allows the H alpha wavelength to pass through towards the sensor, then we can capture the nebulas in the sky very easily. So that is what is called the modification of a DSLR. That means you remove the IR cutoff filter and you introduce a IR pass filter, but it only allows the near infrared to pass. The far infrared is still not allowed to reach the sensor. Now, your question was regarding focusing, but since you were mentioning the ultraviolet filter, that is not correct. And you were mentioning the blue light, blue wavelength, that is not correct. We are talking about the infrared, and the near infrared will come to focus with the same equipment. It is the far infrared which does not come to focus when you are allowing the far infrared to reach the sensor. I hope that answers your question.
Yeah, I still have one small clarification. The IR cut filter can be removed to allow the H alpha, right? So again, someone is saying that if we remove the UV filter also, that reduces the internal reflections, right?
Akshay, I think we can take it offline because we have another 3 questions
Fine.
on.
Yeah.
So you can actually join the Telegram group, then you can actually follow up questions from there.
Sure. Okay.
Yeah. Sorry about that because we are already, 15 minutes away apart from the deadline already. So maybe Aaron, if you want to ask the question, you can go ahead now. Aaron?
Yeah, can you all hear me now? Are you able to hear me?
Yeah, we can hear you.
Okay, great. So I'm actually new to like astronomy, although I've been interested in astronomy for like a very long time now. I've not really got into it completely, and I can see that there are like extreme professionals on this group, and I feel really small. But anyway, I would like to know what would I need to do to begin, or what kind of telescope would I need to actually start astronomy? I know that there are equatorial mounts. I know that there are some really high-end telescopes. But then, what do I need as a beginner to start astrophotography from the ground up?
Okay, I have a few comments. If you want to do visual astronomy, the telescope that you should choose is a Dobsonian telescope.
Okay.
If you want to do astrophotography, you should choose to purchase a sturdy equatorial mount. Now these two are far removed from each other. Now usually people want to do both, and that leads to a compromise. So half of this and half of that. So, but the basic thing is that if you want to pursue visual astronomy, then you should go for a Dobsonian. And if you want to pursue astrophotography, go for a sturdy. Now, this word sturdy is in capital letters, okay? Sturdy Equatorial Mount. Anybody else wants to comment?
Okay, and okay, so we have actually covered the whole mount bit, but then what about the actual scope itself?
Okay, there are numerous types of telescopes available. All have their own advantages and disadvantages. Newtonian telescopes, which use a mirror, they are bad at. I'm getting a feedback from somewhere. Could you put off your mic, please? Okay, if the Newtonian is used for astrophotography, there's a very little back focus. If you use a refractor, which are very good actually, you get blue and violet fringes in stars. So you have to go for you have to go and purchase a more expensive refractor. If you go for a Schmidt-Cassegrain telescope, the disadvantage is that the focal ratio is extremely slow, but it is an all-rounder for visual as well as photography. And there is also something called the hyperstar, in which you remove the secondary mirror of a Schmidt-Cassegrain and place a lens and camera over there, and you have a extremely fast astrophotography setup. So there are plenty of choices with their drawbacks and advantages, and it's quite a large topic actually. Thank you.
Okay, I think
okay, that's great.
Just
Kirti, you want to
Thank you so much.
Sorry. Yeah. So just to add to Ajay's comment, so Aaron, you can also consider using existing lenses. So even if you have a 1855, and this I learned from Ajay, that Canon 1855 is also a very good lens for astrophotography. And so even with that, and with a good sturdy mount, you will be able to take many photos. Even with 50 mm lens, you will be able to take really good images of astronomical objects. So I think you can start with, that's how I did also. I also started with lenses, and I still use lenses. So I have a 200 mm prime lens, and I have a 50 mm f1.4 prime lens, which I use all the time for shooting many objects. And even if you come to our group, you can see that many people are shooting with DSLR lenses. So you can consider them as well before buying any telescope.
And just adding to that, you have also an intermediate, like what Mihir showed. You can have a tracker. You can use your DSLR with something like a 200 mm telephoto lens and put it on a tracker. So you have a mid-range setup where you can really capture very good images of wide field astrophotography images.
Okay, that's great. I think one last thing. Okay, one last thing is that so today we have apps like Stellarium and other apps that actually assist us in finding objects within the actual sky. But I think we have lost that talent of actually mapping out the sky, so that we can actually find things using constellations and where to find what. I think it would be a really good session if we actually take a small session on how to find basic objects in the sky. So for example, if I want to find the constellation Taurus, whatever I look for, what are the stars that I should be looking for? If I have to look for the galaxy Andromeda, which
I understand your question, Aaron. So I think this will be more appropriate on in a star party. So every year we conduct many star parties. So you should join us in our star parties. They are all non-profit events where we just share the cost of going to a dark location and observing from there. And there we have these kinds of programs where, so in the night we have kind of it's a real star party instead of this kind of virtual star party, where you can actually see the sky, identify constellations, and then see objects, and then share equipment with others, and so on.
Okay, even without Aaron asking this question, I wanted to comment that Aaron's question was very generic, but all our answers turned to astrophotography. Everybody. So what I want to say is that visual astronomy, all these the panel members over here today have solid grounding in visual astronomy. That's where we come from, and we have learned the sky by not by photographing it, but by manually scanning the skies. So it's very important. I think it's very important from books. I learned from books. These days, people don't read books. Everything is online, and the attention span is extremely less. So basically what I want to say is that visual observation, you should go for it. It's very interesting. Arcturus is not here today. He lives in near San Francisco, and he would have agreed with me, and he's one of the very ardent visual observers, as well as books. So visual astronomy as well as books gave us all over here, the panelists, some solid grounding, and that's where we come from. And these days, everybody wants to jump to astrophotography without that grounding, and that's why these questions arise, which we are not able to answer. Let me stop over here.
No, Ajay, I think your perspective is correct. Aaron, I think more than equipment, what you need is a 1050 binocular and time. If you invest in those two, I'm sure in a year or two you will be able to identify all the constellations in the sky, all 88 of them actually. So time and 10x50 binocular is more than enough actually. I can guarantee you, because I have done many things like this actually. So with a binocular, you can see a lot of objects actually. Lots and lots of objects from a dark sky. Akash is here actually. So if he wants to answer, he can answer actually.
Not really. I'm in the middle of something.
Okay, all right. Aaron, okay, then Kovi, can you ask your question actually?
Yeah. Are you able to hear me?
Yes, we are able to hear.
Okay. Will it be? I have a Canon 200D camera and a Tamron 150-600 lens. Will it be possible for me to use the Ioptron Sky Guider Pro on the camera to do decent amount of astrophotography?
Anyone taking up this question?
I think Ajay, you can take that actually better.
Mihir, you can also take it up.
Yeah, Mihir, take it up.
Okay, sure. Hey, hi, Kovi. So, Ioptron Sky Guider Pro supports up to 5 kgs of payload capacity. And if you're, I think, with the lens setup and the camera setup you are having, it should be about 3 and 3.5 kgs. So, you can do some great astrophotography with that trick. I haven't showed the setup yet, but it comes with the counterweight as standard, a 1.35 kg counterweight. And you can go ahead and use that to balance it out, and you can definitely use this as a great astrophotography setup. I think that answers your query. Hello.
He's muted. I guess he's not able to respond back.
Yeah, I think he nodded, so I think he's okay. But Sudash, you are on mute. You're talking when you're on mute.
Yeah, okay. Preetham, next, you can actually, ask a question.
Sir, what is the scope of ALTA's go-to mount in astrophotography? I have a Celestron Nexa 8SC, which is f/10, and I have a ASI 224 MC. What deep sky object can I astrophotograph? I'm completely new to astrophotography.
Ganesh?
Hey, there was some break in the voice. Can somebody type the question for me? Sudash or some.
Okay, Preetham,
Or
can
you
you
can
ask
repeat.
your question or type?
You can repeat it. That voice was not
Sir,
clear. That's why you can.
Can you hear me?
Yeah, Preetham, we can hear you. Go ahead.
Yeah.
No,
What is the scope of ALTA's go-to mount in astrophotography?
No,
You
I have a
an-
hearing problem. So your voice is that there is a lot of breaking, so I will not be able to follow.
I'll
Sudash got
repeat
it.
it, Ganesh. Let me ask the
That's all.
question. I'll repeat it for you. Yeah.
I have understood the question, so let me just repeat it. So this is Naveen here. The point is what Pritam is asking is, what is the purpose or use of alt azimuth mount on astrophotography? Pritam, the alt azimuth mount is more of a visual focus rather than astrophotography. So you can go ahead and use alt azimuth mount for planetary photography, short-term exposures, and then you can use it for moon. But then the moment you go taking on a large number of exposures, you will have what is called as field rotation problem. So for that, either you have to software manually autocorrect them, which means processing is too much of a work, and the field keeps rotating. So you can just imagine the whole image, even though you are capturing, let's say, Orion Nebula, from for 2-3 hours, it would rotate for about 25-30 degrees. Not 25-30. It will just move a couple of degrees off. So what happens is you have to change the frame. So it is not advisable to have a alt azimuth mount for astrophotography.
Okay, so I'll just add to this. So alt azimuth mount is not preferable for astrophotography, but you still can use it. There are two ways. One is there is something called wedge. If you have to just mount the wedge to the base of your alt azimuth mount's base, and then your telescope goes on that. So the wedge will give you that altitude adjustment. You can set your altitude, whatever is your latitude there. You set it 11 degrees here in Coimbatore, or wherever you are. So that is one way. The other way is you can still do with the very short exposures. You can do like 10-second exposures or 5-second exposures, and then do a lot of frames. So instead of me doing a 60-minute frame where I do 2-minute frames, 30 numbers, you could do 10 seconds, and per minute you do 6, and then per hour you do like that many. I'm not getting that math right, but do 10-second exposures. Add a lot of frames. You still can do that. I know people who have done that, really very good pictures from alt azimuth mounts.
Okay, all right. I think Naveen has got some clear skies and he has actually set up. For all the folks who are here, who's actually getting late, you guys actually feel free to do whatever you need to do. But otherwise, actually, Naveen is going to show a few objects from his actually setup. Naveenji, all yours.
Okay, team. So you can see that instead of my picture, I've already set it up as a image that I've just captured now. So what you're seeing is the M51 Whirlpool Galaxy at the center. So that's the Whirlpool Galaxy, the one that I have just now captured. Okay. Are you able to see this?
I think it's pixelated, so it's not very clear. In the sense, I think when you're sharing your screen and when we see that it's not coming up at full HD resolution, so it kind of looks very blurry.
Is it? Is it blurry or it is my focus problem?
I don't know, could be both.
So let me just check on it. So what I will do is I'm just going to go move my telescope to a different object. Right now I can see Arcturus there in the sky. So I'm going to just move on to Arcturus, or I can do one thing. I will.
Yeah, I mean, we can see two dots at the center. So two dots very close by, but are they the galaxies? Not sure.
That is the center one is the M51.
Okay. Nice.
Okay. So let's see. I'm just going to move. I'm just going to take up a image of Algor and Mizar. So let's see.
Naveen, when you share the screen, there's a checkbox somewhere that says optimize for video. If you check that, then the resolution should improve.
I am not showing you the screen. What I'm doing is I have just made it as a virtual camera on my OBS.
Oh, I see. Then I don't know how it works. But if you're sharing screen, then there's a checkbox that you have to check.
I think this is the binary star, Algor and Mizar. Not Algor. Sorry, this is Mizar. They were Saptarishi.
Okay.
I think this is where I need to just focus a little. Let me just focus it. So somebody can explain the binary star here.
Kirti.
Yeah, so the binary stars, so usually when you see a star through naked eye, it might look like one star, but when you use an optical instrument like a binocular or a telescope, you will actually see two stars there, or sometimes even more stars. And sometimes these stars are not even so even through big telescopes, they may not be resolved into two separate stars. But when we study the spectrum of those stars, then we see that the light coming from what appears to be a single star is actually coming from multiple stars. And in some cases, so these are called binary stars, right? So in many cases, these are just visual binaries, which means there are two stars which is at the same line of sight as seen from the Earth. So they are at the same angle, so they look to be the same star. But in many of these cases, these are multiple star systems. So there could be two stars which are revolving around each other, or there could be multiple stars which are revolving around one another, and they look like one star. So yeah, that's about it.
Okay, Kirti, what you could also do is, yeah, Kirti, I think that is good if you're sharing it on the screen as well. So I've just put up the capture again, and just to make sure that the star is visible, I am giving a higher exposure. So let's see. Okay, here is the next image. Is it still blurred?
It's kind of washed out in white.
Yeah, you can reduce the. You can change the first thing. You can change the white balance to that 3200 degree tungsten, I think, and then you can reduce the exposure a little bit. It would be okay. And these two stars that you are showing, they are Mizar is the brighter one, and Alcor is the smaller one, right? So Mizar in Indian mythology, this is Vasishtha and Arundhati, two stars. Yeah, but when you photograph them, you see many more stars around, but I don't know what is the meaning of that.
Bangalore skies.
Let me check if I can get the next one. There is a very interesting. Let me just check if I can get a. Just hold on. I'm trying to get a live view.
So there is a question, what is the focal length? I think it's 1000 mm, right? It's a 8-inch f5.
Yeah, this is 8-inch f5.
Yeah, so he's shooting at 1000 mm focal length.
Are they trailing or they are actually double? Oh, trailing actually. Okay, nice.
Okay, can you see the image now? Is the image visible?
Yeah, very much visible. Yeah.
So if you are able to see this image, let me just zoom on to this and then show you. How can I zoom in?
What they're showing double, is that? Is it up?
Yeah, it is a double.
Okay.
But why am I not able to zoom this? Hold on. It's not allowing me to magnify it.
Okay, maybe you can just explain actually. That should be more than enough. I think it's a double, isn't it, already?
Okay, I got it. So let me just stop this.
We can only see your mouse moving. Actually.
Yeah, I got it. That is because I made a big. Yeah, can you see now? Are you able to see this now?
Oh yeah, we can see the double itself actually. Yeah.
So this is the double. So if I just try to reduce the brightness, maybe. You're able to see the difference?
Yeah, we can easily see the difference. It's a double star already.
Yeah. By the way, this is not what you will see through the naked eye. This is only visible when you look it through the telescope. So when I zoom out, you will notice. So you notice this is the actual double stars that are visible from the naked eye.
Correct.
So the ones that you see now, that is a visible naked eye double star. But then when I zoom in, the bottom one is the one that is getting magnified.
Correct. So there is a question associated. Is that a screen share of OBS?
So now I have just magnified the bottom one, and it has gone up by 5 times. So if I magnify, now you can see this. This is the bottom star which is magnified.
Correct. So there is a question from Akshay, which who we asked actually, is that a screen share of OBS?
This is a screen share of OBS, but then this is a big golmaal that I'm doing in the background. This is the binary star you can see now. So what I have done is I have connected my, I will show you the setup. So this is the binary stars. I've just reduced the exposure settings. Okay, for people who wants to see my setup, let me just show you. Don't get scared with the setup. Okay.
I have pinned both of yours actually. Now we can see a laptop.
Can you see my laptop now?
Yep, can see.
Not the laptop. I want you to pin my other one.
Yeah, you need to change focus probably. Are you logged
Done.
in?
Let me just make it. Let me just make it. Hold on. Okay, now this is better. Can you see it?
Yes.
Yep, you can see.
This is my telescope setup. Okay, so it's an Equatorial Advanced VX mount. So all the golmaal that I have done is, you see, let me just pick up the light for something. Okay, so what you see is I have connected the camera to the telescope. Okay, so here is my camera and the telescope.
Naveen, your voice is breaking. Naveen can't hear you. Naveen, you are there?
Yeah, can you hear me?
Yeah, I think you have some echo.
Hold on. Okay, now you should be able to hear me.
Yes, very clearly.
Okay. Okay. So here is the camera that I have set up, and you can see that Equatorial Mount, Advanced VX mount, 8-inch telescope, Celestron 8-inch Newtonian. And what I have done is I've connected a lot of cables. So the setup is like, I am trying to, if you see, I am trying to connect my camera through the Canon remote setup. I am using a live view here, okay, so that I can use this. So you see this, I can move the star, okay, and then this I have connected it to my OBS, and that is where the OBS setup is the one that is being shown. Okay, that's the whole setup for connecting.
Okay, fantastic actually. So
here,
there was a question on the chat. Is there a way to do this to Centauri system using the same setup?
Centaurus, the Centaurus is right now too low, I think. Unfortunately, the weather is not so clear.
Even on a clear Bangalore night, actually, Omega Centauri looks like a simple blob actually.
Yeah.
Nothing more. So it's pretty difficult actually to do from Bangalore, but I'm sure you should be able to do it from Coorg or any other darker locations.
Oh, from a different location, this setup is awesome actually.
Yeah.
It will give you. I have Arcturus on the top. I don't know if you can see my sky. No, sky is not seen. It's all dark.
Sky, obviously, probably we can't see. Okay then.
So I'm going to pause this one. Okay. What I'm going to do is I'm going to just go on to show some of the clusters. Let's see if I can find out some good places. I personally like some clusters, so I'm just going to point to them.
Clusters are mostly in the east now.
Yeah. Let's see which one I can point to. If I can get some view, I'm going to do it. Unfortunately, this is the segment where we have a lot of galaxies, but from the city it is difficult. So we have to.
Yeah, exactly. So we are off by about 2-3 hours actually.
Yeah.
You have the bright M5 in Bootis.
Oh, Bootis M5. Okay, let me just point out to that. That's
or even M13 will be nice actually if you can focus.
Okay, team, let's see. I'm just pointing the. I can get some view.
Akash has corrected me. M5 is in Serpents, which I said, but M3 is in Bootis.
Move to M5. Let's see if it is going to be captured.
I mean, even M5 should be visible actually. It's only a 6.5 magnitude, so it should be visible.
Beautiful. Hold on, guys. M5 is coming up beautiful. Okay. For this, I need to just go ahead and change to this one. So this is M5.
Wow, pretty nice. This
Yeah,
is
this is nice.
in English terms, it is called as a rose cluster actually. So you can see the petals actually forming up.
Yeah, this is the M5. Beautiful. Thanks, Ajay. This is coming out good. So what I could do is probably change the white balance. So explanation on this is a globular cluster. So what is a globular cluster? Globular clusters are those which have tens of thousands stars more compact per unit area for in the space. I mean, an open cluster will have lesser stars, and these are gravitationally bound, more compact object. One of the theories also says that it is it is going to be like sources for bigger galaxies to form, and usually they are formed on the halos of the galaxy. Yes. Can I zoom? Unfortunately, I can't zoom, and this I can't show it as a live view. So the moment I give it to a live view, you will only see one small star. I can show you the live view. So you see this star here, the one that you see on the screen. That star, you can see that star in the screen. So now you see
okay.
So
Yeah.
this is the live view, and this one is the 15-second exposure. So I think this is where what Ajay was doing, capturing and overlapping it. That was a beautiful way to.
Especially from the city skies, I think it is a beautiful way of actually illustrating an object.
Yeah. So probably if I don't know if I can do it on this system, but if it was possible, then from single star you would have started seeing this object emerging out.
How about M13?
Okay, this is the same picture, but I have just changed the contrast. I mean the ratio. That's it.
Right. Yeah.
Let me take one more image and then we'll move on.
Yes, sir.
Okay, what is the next object? Booties.
In boots, we also have M3 actually, your globular.
Okay. Yeah, so now I think now it is much better.
Oh, now it is, definitely better,
Let's see if I can get one more.
Oh, it's nice. I think it is the screen being shared is a problem.
Yeah, probably we are trying to, see this.
Yeah, now we can see a lot of individual stars actually inside it.
Okay. So if you are able to see the stars, globular cluster.
Fantastic.
In fact, for people who are on the videos and watching this, when you look at this particular object through a telescope, it appears. I mean, you will be able to see a lot more stars and resolve it. Visually, it is much more appealing. Yeah. Okay. Let me just go to M3 now.
No, as Akar suggested, can we do an open cluster? I have one candidate for it actually.
Tell me open cluster in the same region, then it will be easier for me.
Oh, same region, is it? Okay, not exactly in the same region.
The point is my telescope shouldn't move too much. That's all.
Okay, this is called the summer beehive actually. It's IC 4665 actually.
Okay, let's see if I'm able to get it. This is M3. I'm trying for M3 now.
You could try next. You could try open cluster beehive or M67, the Cobra. Both are in Cancer, but they are in the opposite part of the sky.
Yeah, beehive is already gone beyond this one, isn't it? Very low in the sky, isn't it?
Moon is still there, although I am at Delhi, so.
So in Bangalore, it is probably at 15 degrees or so.
Okay.
Okay, guys, this is M3.
Looking good. Looking good.
Wow.
This is
on first glance, it looks like M13 because of the two stars on either side of the globular cluster. But if you look carefully, one star is a little further away, so it's not F13.
This is good. You can go ahead. Let me just take probably one more image of this. You can just shortlist the candidate for the next one.
I don't know. The other day I saw, IC 4665. It was amazing actually. It is actually directly, I think somewhere below. There below that Ophiuchus actually, yeah. Ophiuchus.
Okay, give me the number. I'm gonna try it out.
You have a go-to, is it?
I'm not using that as of now.
Oh, okay. IC 4665.
If I go with the go-to, then it is going to give me random objects in the sky. I want it in a specific region.
Okay.
Hold on, let's check clusters.
There are actually a lot of them rising actually.
I'm moving it to Hercules. Let's see if that is visible.
Yeah. I think that part of the sky is actually pretty good. Looks like actually. Yeah. You don't want to try Cigar board, is it?
There's a lot of cloud there. That is why.
Okay.
I mean, M35, M51 is where it is barely visible. I mean, not visible, clouds around it. Okay, let's check for this. This is hold on, it's still coming up. Okay, it's loading now. This is M13.
Oh, yeah, M13.
Much bigger and nicer. You can see the outer smudge of stars.
Right.
Very true, yeah.
But there's a cloud moving in on top.
Unfortunately.
I
am glad that I'm able to show you at least 3 globulars as of now.
Wonderful, really.
It was fantastic actually, yeah.
Yeah, for people who wants to see it as a live view, so let me just show you the live view. This is the live view.
Nothing visible.
That's why virtual star party has to be only a photograph.
Yeah. Okay, I'm just trying to move that star so that let's see if it can be in the center. Taking a second snapshot of the same M13. Give me an open cluster. I was actually loving this number 3 cluster.
There is not many actually there.
There are not many open clusters available in the sky at this moment. All globular and mostly galaxies only.
Correct.
The highest is your Ophiuchus actually, because I looked at it at the same time actually a few days ago, or maybe a week ago or something like that.
The light that you are seeing probably might not be the cloud. I understood. I was actually trying to lit my telescope, right? So it is a background light. So let's take up another image of this.
Okay.
Because it is consistently showing up in my image. I just realized. Let's see this image.
Okay.
Okay, so now you can. So this is the cluster. Beautiful.
Very nice.
Neat. For 15 seconds, it's amazing actually.
Yeah, 15 seconds, ISO 1000. I don't think if we go to the higher ones, it makes any sense. This should be good enough.
Kovi, you can ask your question.
So maybe you can on the chat for us. We'll hang out over there. It will be better.
Chat is open actually. You can't type into the chat?
No, it's disabled for us.
Kovi, if you hover your mouse over the screen, there will be an icon appearing below on the lower part of the screen which says chat.
It was disabled for all. I have just enabled it. You can try it out now.
Okay.
Okay, I'm just going to move. Hey, Sombrero should be available, but I don't want to. Okay, let's see.
Cigar board is actually brighter.
I'm trying out Sombrero Galaxy. Let's see.
104 is it?
Yeah.
I thought your board is actually much brighter than Sombrero.
What was that? To improve SharePoint, do not click optimize video options when sharing. Okay. Let me just check. I have put my video as high quality. I have not optimized my video, so it should be at the best option. Okay. Looks like it is pointing to something that is sensible. Let's see. Okay, for people who are new to telescopes, you could see that I was able to move my telescope to different objects on a click of a button. That is what is the advantage of go-to telescopes. But this will kill your amateur observation life. So I would say do not use it too often. Okay, we have this. We have the galaxy, Sombrero Galaxy. Can you see the Sombrero Galaxy here?
Oh yeah, something is there. Yeah, definitely there. Yeah. I don't think we can see the hat, but yeah, some smudge is there actually. Yeah.
So that's the Sombrero. You could see that I was able. Let's see if I can make it a little more. Okay, Preetham, I am in Bangalore city, so it is horrible skies here.
Okay, Naveen, I think it is about 3 hours into the session. So shall we close?
Can you tell me any cluster. I want to show a globular cluster. I mean, open cluster.
No,
3242. What is 3242?
That is Ghost of Jupiter. That's a planetary nebula. So I was, it's high surface brightness, so you should be able to catch it from the city. But it'll appear like a tiny defocused dot.
Yeah.
I was just what do you call skipping that. So let me just show you that. Ghost of Jupiter.
It's in Hydra.
Hydra is too low. I doubt I will be able to see it. It's just okay. Right now, I think I increase the exposure ISO so you can see the what is this sombrero here. This is the galaxy. Okay, let me
For
check.
us, it is still the white washed out actually one.
Akash.
Yes.
Your object is available, but I can see it. I don't know if you can notice it.
I guess I can notice it, but it is very indistinct. It just looks like a star.
Okay, I've just reduced the. Right, let me just take one more image. Be much better now. Can you see?
Yeah, it's a lot better. I can even see the color.
Oh, I mean, I thought that only my eye is wrong actually. This is a greenish blue tint, is it?
Yes, the bluish green color.
Yeah.
Nice. Not bad at all.
This is the Ghost of Jupiter. Okay.
This is one of the few objects, especially as a beginner, that you encounter that you can see color in visual observing at the eyepiece. So if you bring it into an eyepiece, even in a 6-inch or 8-inch scope, you can see the bluish tint. Generally, only planetary nebulae, you can see some amount of color.
What configuration did I change? On my Stellarium, I am unable to show any DSO objects. I have blocked all. Okay, it's here, GC. Okay. Okay, let me show you now all the objects that are required. M3 is done. All the clusters are setting.
Yeah. I mean, rising rather actually. Open clusters.
M3 Auriga is not there.
Auriga is already set actually. So. Oh, it's okay, Naveen. I think we should actually conduct one more, virtual star party is pretty clear actually. So
I think if you want, you can. Sorry to interrupt. I think if you want, you can try to hit Melot 111, which is that Coma Berenice's region, right? It's a very big open cluster, which is completely resolved to the naked eye. So I don't know how it'll look in your camera, but that's the only one I can think of.
Okay, let me just check on the, what is this, Leo cluster first, and then I will check. Let me check on the Leo cluster. Leo triplet. I never expected that we will be seeing so many things actually. Okay, I don't know what is. I've put M65. Let's see if it is visible. Oh wow! Can you see? Can you see the galaxy here? 1 and 2. Is it visible?
Yes, it's visible, but very faint. Would you mind changing the view, or is this the view that shows more?
ISO is very faint, so let me just increase the ISO. Okay, now it is whitewashed. Is it whitewashed?
Not whitewashed, but slightly better than before.
Okay. So it's a Leo triplet. If you can show me the third galaxy, I will agree that you have been seeing. Anybody can go ahead and tell me the location.
Naveen, just for a second, I think there are other presenters also who are just waiting in the call. So let's first conclude the session. We can continue this if people are interested. They can still be there. But first, let's thank all the speakers and conclude the session because we have already overshot the session by more than an hour. Okay, so and then you can continue with the objects. So Sudash, let's conclude. Do you want to do that?
Yep.
Thanks.
Okay. For all the participants who tuned in till now, we have sorry that we have overshot by almost an hour plus. Thank you for being there, and thank you for all the wonderful presenters who actually did their best in spite of all the bad weather that we have had, and all the luck that we have had in terms of weather. Thank you so much for everybody for tuning in both in YouTube and in Zoom. We will still continue because I think the sky is actually pretty clearing up. So all those who want to carry on, please carry on with your actually plans. But otherwise, if you want to see some objects, Naveen is always there actually. So the session will continue, and it is still live stream in YouTube. So whoever is actually want to continue, you can please actually continue. There is no issues at all. Okay, thanks everybody. Bye.
Okay, bye.
Bye,
Thank
Ganesh.
you, everyone.
Bye, Ajay.
Yeah, thank you so much. Thank you so much for everybody. It was awesome.
Naveen ji, continue.
You keep. I mean, I will make it this way. Please go ahead and tell me the object. I'm going to point it. Let's do it that way. I want people to just let me know the object. I can point it. Okay, board and cigar. You want me to point it to board and cigar?
Can you tell me what constellations are visible?
I would prefer.
Whatever you prefer to say.
North, northeast, and northwest.
Yeah, but I don't know what constellations are up. So if you can just tell me what constellations are generally seen, then I'll try and think of something.
Do one thing, Akash. You just let me know you just tell me the object. I will find out, and then I will tell you whether it is feasible or not. Okay.
Okay.
Okay, so for people who are looking at this image, did you find out where is the third constant? There are 3 galaxies in this image. Did you find out where is the third galaxy?
We can only see 2 smudges actually. The third one is not there.
Okay, the third one is not there. Let me just show you and let's see if it is possible for you to see it. Okay. Do you see at 8 o'clock position? Here? This one?
No, cannot see.
Okay. How do we set things?
Probably share it as an image file in the chat box so that people can click on it and see.
Yeah. Let me just check. Let me just do something else. Image file, the problem is I am trying to take up in a high resolution. So it will be like 40-50 MB raw file. Let's see. Is this visible now or is it still blur? Okay, Akash, next object.
I'm actually out of ideas. Other than, like I said, I'm not into star maps, so I don't even know what constellations are your sky. I'm just trying to guess. You can do some bright galaxies like M61, for example. M94 is bright, but they're all individual galaxies. And the only group that I can think of that is well placed right now is 644. But I think it is too faint for your telescope unless you expose for a long time.
Yeah.
So I'm not coming up with any ideas other than individual galaxies.
Okay, let me see. I have put it to board galaxy, board cigar. So let's see if it is visible. I'm capturing right now. Do you think it is better for me if I do a screen share or? Oh, wow, this is visible. Both board and cigar.
Yeah. Both of them visible, very clearly visible.
Oh, yeah. Okay, you can.
I think you have to point out, where the objects are actually. Is there a way to, dim the whole background and all that? There's a lot of white actually there.
I don't know how to dim this. I mean, I may have to do a mapping itself. 1502 NGC. Okay. I don't know. I think I may have to go ahead and what do you call? Edit the file.
Oh, okay.
So unless we edit, I
heard about this 1502 cluster.
Let me just check. Okay. Meanwhile, I'm gonna. I'm just going to take up one more exposure of this board and cigar. So let's see if it can be better. And I will try to see if I can send some images as well. Okay, did it improve or did it worsen it?
It worsened it actually. I mean,
Okay.
because I've seen the object, I know where the object is actually, so I can see the object.
Okay, let me just put up the latest image. Hold on. 86, 87.
GC6231. Where is it actually?
Okay, I can do one thing. I can
False comment. Oh, okay. Oh, okay.
Okay. Okay, guys, I am just uploading the image to the chat. So you can go ahead and download the image to the chat. That's a lot better. Or I think the best way for me to do it is more than a chat. I'll give you an access. Hold on just a moment. Folder. Okay, for all those people who wants to view, I'm just going to copy my images to this this folder. You can keep this folder open, and I'm going to copy it to this, so it is easier for you to look at the objects. Is that okay? Okay, I have uploaded some of the images. It will take 2-3 minutes for you to get it. Okay, the next object, board and cigar, is done. What else?
If Lyra is well placed, Wing Nebula.
Lyra, I can actually see Vega. Let me just check. Okay. Who is the next presenter available? We are done, right?
Yes, sir. No one. Everyone's done.
Oh, thanks, Rahul. So you are able to see the image. Good. Okay, so let's see what is the next object. It says this is a asterism, so V-shape, coma of star cluster. Let's see.
I think coma is too big for your scope.
No, there's a cluster in coma. That's all. Let me check. It's not even visible. Oh, can you see the V? Can you see V? Inverted V?
Yeah, I can see an inverted tick mark actually. That is what you mean.
From the center to the 11 o'clock and then back down.
Yeah.
You see this?
I mean, from the center, 11 o'clock. Yeah, correct. On top.
Okay. I'm just randomly using the Stellarium. I mean, what is this? The telescope go to and then pointing out to some random objects, trying to find out some clusters. Let's see. So this is one more cluster. This is called as Stargate cluster. Is it? I think the focus is also off by a little. Okay, the next object is coming up. Wow. I have no idea what is this Stargate cluster. Ah, I think this is the object here at the top. This one looks like a star. Okay. (7822) NGC 7822. Just give me a moment. Let me just point it to it. Okay, this is completely whitewashed. Hold on. Okay, if somebody can identify this object.
This is clouds actually.
Behind the cloud.
Behind the cloud. I can't see anything.
I think actually it is in a very good position. So remind me of this cloud object. I will show you later. Okay. It's a very interesting.
Okay.
Okay, what was the cluster deep sky? NGC? Somebody messaged saying that from Delhi it is visible. Who messaged it? Let me just check.
Manjari Mitra, NGC 7822.
NGC 7822. 782. We need to just check. Yes.
NGC 7822 is already set here actually. It is -5 degrees altitude.
Thanks, Srinivas. Appreciate that. Oh, man. Whoa. NGC is way down, man, below pole star. So, okay. NGC is not visible in Bangalore, so off.
You're on this one, is it? Go-to, is it?
Yeah, that is how I am able to show you so many things. Otherwise, how will it be?
Okay, then IC is 4665.
IC?
4665.
IC.
Ophiuchus.
5. What is this? I remember looking at this object. Ophiuchus is just behind my room, man, so I don't think it is going to be visible.
Oh, is it? Oh, okay. Oh, you don't have access to East, huh?
Let me check. Hold on. Ophiuchus. Yeah, it is. Okay, let's see what is Ophiuchus going to come up. Okay, ready?
Oh,
wow.
Visible.
Wow. Yes. Yes.
Awesome.
Okay. Please go ahead and pin this. And let me increase the exposure so that we get brighter.
You're already pinned, actually.
Okay. No, it is not. If I pin it, only my image will come up. Okay, let me.
No, it says actually remove pin.
Removed pin.
You're already pinned, actually. This particular window is already pinned.
No, it is not. Okay, oh, sorry, Rahul, I'm just sharing it. Hold on. Okay, I need to share the image. So I'm going to share this image. Thanks for reminding, Rahul. It is okay. I have just copied the Ophiuchus NGC, not NGC, IC 4665.
Yeah.
It will take 2 minutes. It's just uploading. Okay, NGC 4665. Nice one.
Okay, in fact, I need to probably explain it actually.
Yeah, please go ahead.
Okay, the way that you see, the thing is, I think better is to share the screen actually. Let me share my screen.
I've just copied the image. It's going to be easy.
Okay, so if you guys actually see my screen, you see the summer beehive cluster actually. So you will see these, one arm here, the second arm here, and the third arm here actually. So this is the cluster actually. So you should be able to see that in the image that Naveen shared.
Do we have something in Libra?
Except for the binary stars, no, not much actually. The Zubanshan Mali and the Zubanshan, both of them are binary stars.
Okay. Any other? Are there any galaxies? Just check.
How about your? Sorry.
Let's check if there is any comet with.
Comet. I have zero idea where the comets are. Actually. Comet. Wow.
Let's see. Comet. Change this.
How much of access you have to your eastern sky?
Huh?
Or southeast?
Southeast. That is where it is blocked. Actually, southeast is the big tree. I can't.
Oh, okay. No, that is where all interesting objects are actually rising now.
That is where it is rising. Actually, hold on. I have a new next object, but I don't know if this is going to be. Oh, in Leo. Okay. Let me just check.
You mean that asteroid?
Huh? Not asteroid, comet.
Oh, then I don't know.